Hello, my dear NEET warriors. Welcome to the Vedantu NEET English channel. And this is your big monster, which is none other than rotational mechanics. Everybody is scared of this monster. And if you are scared of the monster, put up a monster emoji. If you can find it in your keyboard right away, right now, because we are going to tackle this particular monster in this particular session. And I'm going to tame this monster for you. I'm going to make sure this monster calms down, and in fact it gives you marks in this upcoming NEET examination. So my dear students, are you ready for this amazing session with me for rotational mechanics? We are going to have NCERT problems, back exercise, in-text problems, all the important ones. You will see most of the problems will be covered in today's session. And the flow of the session will be, we'll start with the concept of rotation, then we'll go to moment of inertia, we'll go to torque and angular acceleration, then equilibrium, then rotational energy, angular momentum, and then conservation. So that's the flow of today's lecture. Nice to see all the Josh out here for your none other than Captain Shreyas on your screen. Hello Sneha, Lakshmita, hello It's Cute, Nigamat, hello Rutuja, Saiti, Ridigna, Balaji, Pavni, Satya, good evening, thank you. Yes, I love you too. I am your captain. Gojo is here too. Very nice to see you, Banot. Hello Rishika. Good evening, good evening, good evening, my dear warriors. Hello Alam. And those of you who do not know me, I am from NIT Nagpur. I produce the top-notch ranks in the country, be it JEE, be it NEET, be it KVPY, be it some Olympiad, and I'm very happy that my students are performing really well, and this year too you are going to make me proud. Smash the like button to show your support, and also subscribe to the channel in case you haven't done that yet. Okay, so make sure you are also a part of the Telegram channel. That's where you will get all the important updates. The PDF of today's class will be there as well. Hello Krishna, happy evening to you too. Happy evening, love you too, Rutuja, love you too. Thank you, Satya, thank you so much, my dear students. So let's begin with the class. Call all your friends. The session has just begun. By the way, this session is going to be very long. So be prepared, okay? Be prepared. Now, let's talk about rotation versus translation. Rotation versus translation. So what happened one day? You know, Champa, this is your beautiful Champa. Like this. She had skaters or she had rollers on her feet, and she rolled towards Pandu like this. She rolled towards Pandu, okay, like this, in this particular direction. Another day, Pandu was not there, so Champa wanted to do time pass. So what Champa did is, she was alone in the house. You can see Champa is not that happy as such. She still has those roller blades. She still has those roller skates on her feet, and she is just rotating. She's just rotating like this. Okay, she's spinning basically like this. She's just practicing over there. This example, the first example is of which kind of motion? And the second example is of which kind of motion? This is an example of translation motion, right? Translation motion. And this is an example of rotational motion, correct? Now, by the look of it, you can say Champa is translating, Champa is rotating. But physics-wise, how do you define translation? How do you define rotation? Simple. Tell me one thing. If the hair of Champa moved 5 meters, how much did the feet move? How much did the legs move? How much did the hands move? How much did the eyes of Champa move? Answer in the chat box. More than 5, less than 5, equal to 5. More than 5, less than 5, equal to 5. Champa's hair moved 5 meters. So Champa's feet, her legs, her hands, her eyes, How much did they move? Answer is, my dear warriors, 5 meters only. Obviously, imagine Champa's hair moved 5 meters. But Champa feet moved 10 meters. Champa's hair will come out like this. Champa's hair will come out like this. And the remaining Champa, oh my god, this is like bald Champa over here. How can that be possible, right? Not possible, yes or no, my dear warriors? Yes or no, my dear warriors? Yes, very good. So, what is the point of translation? In translation, my dear warriors, all the particles move the same amount. All points on the body, move same displacement, Is that right or no? Very good. Excellent. Everybody understood, sir. Yes, sir. How can Champa's hair move 5 and body move 7 and their hands move 6? It will look very weird. Champa will look disfigured. Champa is looking so beautiful. Let's keep her beautiful, sir. Okay, very good. Rotational motion. In rotation motion, Champa is rotating like this. Will all the particles have the same speed? Yes or no? Come on. Champa is rotating like this. Will Champa's all particles have same speed? Yes or no? Yes or no? Is the speed going to be same? Yes, or all the speeds will be different? What do you say about this? Come on, answer this. Yes, Champa is very famous, Priya, because of me and because of you too. Is that a minion Champa? Kind of. Okay, many of you are saying no. Shreya saying yes. No, Shreya. I know your name sounds like me, but sorry, bacha. The answer is no. Because think about it. If you look at it from the top, then you'll realize the particles which are far away, they move in large circles. Particles which are close, they move in small circle. Yes or no? This particle over here will move in large circle. This will move in small circle. So each particle is going by a different amount. When you rotate, each particle will move via different amounts. Yes or no? So speeds, are they going to be the same? No. But one thing is there. If any particle covers certain angle, then other particle will also cover the same angle. Angle will be same. Whether a particle is here or the particle is there, the angle covered will be same. Whether the particle is close to the axis or whether it is far away from the axis, in the same time they all cover equal angles. So can I say all the particles cover same angle? Here it was same displacement. Here they cover the same angle, obviously in same time. Same like over here, same displacement in same time. That is the main difference. Are you able to see now? Are you able to see this difference now? Everyone? Very good. Now there is one or maybe some set of particles on Champa which are not moving only. Is that there? Yes or no? I think there are some particles on Champa which are not moving only, which are not having only any speed. I think it is just like when you turn on the fan, or just turn on the fan. If you have a fan in your room, just turn on the fan. You will see all the particles are going round and round, but only that point at the center is not moving. It's just there. It is not moving. It's just there. It's not changing its position. And that is precisely the axis of rotation. That is precisely nothing but the axis of rotation. So that doesn't move. That doesn't basically move. Is that very clear, my dear warriors? Is that very clear, my dear warriors? Yes, the axis is constant. Correcto. Perfecto. Now, going ahead in this discussion, what is the meaning of rigid body? What is the meaning of a rigid body? A rigid body is basically, it is, you cannot deform it. It can't be deformed. It can't be deformed. It can't be deformed. The examples of that are like stone or wood, or let's say a metal object, right? The things which are not rigid bodies could be things like a chewing gum, clay, cheese, right? Water, gas. All these are examples of non-rigid bodies. Although stone, wood, metallic objects and many such, strong objects, they can be slightly moved. We ignore their deformations, small deformations, but on a general basis, they are not, going to change their shape or their size very significantly. They are going to have very negligible changes, minute changes. So that's the reason why we call them as rigid bodies. And these rigid bodies is what we study in today's lecture. Now, one such parameter about a rigid body which you should know is basically angular speed. Angular speed, you might have studied this in circular motion, but still we'll just do a quick recap. We'll just do a quick recap of this in case you have forgotten. Imagine if there is some body like this and that body is hinged over here, or this is the axis, and after some time maybe it goes like this, So you can see that this body has covered certain angle delta theta. So the delta theta is the angular displacement. It is the angular displacement. In a time of delta t. Then your angular speed omega is just given by delta theta, the angle covered per unit time. It's nothing but the angle displaced upon basically the time which is taken to displace it, delta theta by delta t. But this omega is the average angular velocity. Omega is the symbol of angular velocity or angular speed. But if you want the instantaneous angular speed, then what will happen over here, my dear students? What will happen? Let's see who are the smart genius NEET aspirants who are cracking this now above 700 plus. What will you do if it is a very, very small angle? What if it is a instantaneous velocity? Then the delta will become very good. Some of you are going to write this now. Very good derivative. So it will become d theta by dt. That is the change. Some things which you should know. So omega average is delta theta by t. Omega instantaneous is d theta by dt. Okay, that's number one thing. Another important recap which we need to do is about angular acceleration. It's just like acceleration but in angular terms. So say for example, there was some object over here. It is, let's say, hinged over here. This is the axis over here, pivoted over here, hinged, axis, pivoted, all are very similar. And let's say that particle or that body becomes like this. So here it had some angular velocity omega. But that velocity only changed because it was accelerating. Maybe here it had omega plus del omega angular speed. This is its new angular speed. This is its new angular velocity. This was its old angular velocity. And how much time it took from here to here? This was in a time of delta t. In delta t time, this was the new angular velocity which it got. So my dear warriors, doesn't it now have something called as angular acceleration? Now doesn't it have something called as angle wise it is accelerating? Symbol for that is alpha. In linear mechanics we used to have a, acceleration a, here it is alpha. So that alpha is nothing but how much is your change in angular velocity, upon how much time was taken. So that alpha on an average will be del omega by del t. Del omega by del t. What will be instantaneous? Let's see how many of you can write that formula quickly in the chat box. Quickly in the chat box. So if there is something which is rotating and then the speed is increasing, first it is slow, then it increases. So initial angular speed omega, after some time omega plus some extra amount. That extra amount is the change which I have put over here. In how much time did it change? Delta t, that I have put it over here. So how much did it change? How much did the speed change per unit time is the angular wise acceleration. Like we had it in meters per second square, here it will be in radians per second square. Yep, very good. Many of you put the correct answer for this. Yes, this is instantaneous, which is d omega by dt. If you talk about the units, of omega, it will be in, check this out, angle is in radians, time is in seconds, so radians per second, that will be the unit, radians per second will be the unit. But over here, already this is radian per second, so what will be the unit? What will be the unit? It will be radians per second square. Radians per second square. So that will be alpha. That will be nothing but your alpha. Keep this in mind. Let me just put it right over here. Let me block the results, whatever are important. Cool. So say for example, I give you a very, very easy peasy lemon squeezy example. A fan rotates at 300 rounds per minute. Find the omega. Find the angular velocity. Okay, let's try to do this question, my dear students. 300 RPM. R is round, P is per, M is minute. Rounds per minute. We want to find omega. Omega is usually expressed in radians per second. Okay. So what do we do now? How do we tackle this problem? See, if I tell you it is rotating 300 rounds in 1 minute. 1 minute is how many seconds? 60 seconds. So can you tell me the number of rounds in 1 second? In 60 seconds, these many rounds. In 1 second, how many rounds? Obviously 300 divided by 60 rounds. 300 divided by 60 rounds. But we know, what do we know? One round is how many radians? One complete round. How many radians, my dear warriors? Come on, recollect trigonometry. I have told you about this. Yes, 2 pi radians. 2 pi, 360 degrees, but in radians it is 2 pi radians. So if one round is 2 pi radians, these many rounds will be how many radians? Therefore, the angular speed in radians per second will be how much? 300 by 60 rounds. Each round is 2 pi radian. 300 by 60 rounds. These many rounds. Each round is 2 pi radians. So into 2 pi. How much will it come out to be? 60 goes with 300 5 times into 2. That will be 10 pi radian per second. 10 pi radian per second. Did you understand how to convert from RPM to radians per second? Will you be able to do from radian per second into RPM also? Will you be able to do from radian per second into RPM also? Let's see whether you can do it really quickly, my dear warriors. Example, omega is 25 pi radians per second. Find in rounds per minute. Find it in rounds per minute. Come on, let's see how many of you can do it very quickly. Let's see if we can do it very quickly. Over here, if it was in RPM, what did we do? Let's see. If it was in RPM, what did we do? The RPM value, you divided it by 60 and multiply by 2 pi. That is what we did. That was the trick. You found it per second and multiplied it by 2 pi to find it in radians per second. So if radians per second is given, RPM is asked, exactly opposite, bring the 60 on the top, divide it by 2 pi. Take this 60 on the top, take the 2 pi below over here. So what will happen? Omega, that 60 goes on the top into 2 pi, whole thing, 2 pi will go below, my bad. 2 pi, omega, this 2 pi will go below and that 60 will go on the top. Is that right? 60 went on the top, 2 pi went below. That will give you in RPM. So substitute the value of omega, it is 25 pi by 2 pi, whole thing into 60. Everybody with me? Pi went off, correct? Pi went off, 2 goes with 60 how many times? 30 times. 30 into 25 is how much? 750 RPM. 750 RPM. Very good. You guys got how omega is calculated. Okay, let's see if you guys can do this. If angular acceleration has to be found and what is given to you is omega changes from 2 pi radian per second to 8 pi radian per second in 3 seconds, find how much is alpha. Okay, come on guys, think about it. Find angular acceleration, that's what they are saying. If omega changes from this value to this value, just go back a little bit, you will understand angular acceleration is how much is the change upon how much time it took. So in this particular problem, how much is the change in the angular velocity? How much is the change? This is final, this is initial. This is final, this is initial. So the change will be 8 pi final minus 2 pi, which is initial. How much is the time? 3. 8 pi minus 2 pi, 6 pi by 3, which is 2 pi, but it will be radian per second square. Everybody understood how to find alpha? Everybody understanding this? Pakka? Very good. Okay, answer this one last question before we go ahead. Omega and alpha, I'm just going to give you the signs of it and you are going to tell me whether the speed is increasing or decreasing. Whether the speed is increasing or decreasing. Increasing or is it decreasing? Come on, tell me my warriors. If angular velocity is positive and angular acceleration is also positive, what do you say? Is the speed increasing or is it decreasing? Is the speed increasing or is it decreasing? Come on, put up the answers in the chat box. Is the speed increasing or is it decreasing? Angular velocity is positive, angular acceleration is also positive. Both are in the same direction. It will increase the speed. Won't it increase the speed, my dear students? Won't it increase the speed, my dear students? Everybody with me on this? Very good. Angular velocity is positive, angular acceleration is negative. What will happen now? It is having velocity here, but acceleration is opposite to it. Acceleration is opposite to the velocity. So, will the velocity increase? No, no, no. It will definitely decrease. Very good. If you wrote decrease. Excellente, my dear students. Similarly, if I tell you this is negative and this is positive, this is negative, this is positive, angular velocity is in one direction, acceleration is in an opposite direction. If velocity and acceleration are in opposite direction, the speed will reduce. If it was moving fast, it will start moving slowly. Correct? So, again the answer should be decrease, yes or no? Yes or no? Very good. Lastly, if you can answer this question, I will right now call AIMS director and book your seat. Right now, I'll call AIMS director and I'll book your seat right now. Come on. If both are negative, my dear warriors, what do you think is the answer? Both are negative. What do you think is the answer? The answer is yes, it will increase. Both are negative means both are in the same direction. So they will increase the speed. If it was slow, it will increase. Yes, I think I have to book the seats for Siddharth, Vara, Shreya, Krishna, Lakshmita, Alam. So many people. I have to increase. I have to book the seats. Okay, I'll take a screenshot. I'll send it to the AIMS director. He will reserve the seats. Don't worry. Okay. Awesome. Now, having said this, if there is a particle which is going in a circular motion and the radius is basically r, then it has something called as the velocity along the tangent, because if you draw a tangent, that is how the tangent will look. This is also called as the tangential speed. I have a feeling that the omega or the angular velocity has a relationship with this velocity. Angular speed with this velocity. Yes, what is that? This is basically your tangential speed. This is basically your tangential velocity. Tangential velocity. What is the relationship? The relationship is Vt is equal to omega angular speed multiplied by r. Vt is equal to omega r. That is the relationship. More omega, more speed. Higher radius, also more speed. Yes, it makes sense. It makes sense. If you take the example of a fan, okay, something like this. Notice how when the particle is close here, the speed is less. When the particle is far, the speed is more. Even farther, the speed is even more. As you go close to the center, the speed becomes less and finally becomes zero. So when you are far, the speed is more. When you are close, the speed is less. So it is small here, it is more here, and it is the highest here. So as r increases, speed increases. As the radius increases on that same body, the speed increases. Is that clear? Everybody with me? And if you guys are understanding, if you people are understanding, if you warriors are enjoying this session, do not forget to smash the like button right away, right now. Show your love, show your support, means a lot to me and the entire team. Okay? And also subscribe if in case you haven't done that yet. Similarly, if I have a particle which is going in a circular motion, and let's say the radius is r, then if it has something called as the angular acceleration, then this point over here has nothing but what? Just like tangential velocity, it will have tangential acceleration. Tangential acceleration. How much is the value of this tangential acceleration, my dear warriors? Same, just like before. Just like V was omega r, tangential acceleration is angular acceleration into r. That's all. That's the formula. It's very, very identical looking formula. V is omega, AT is alpha. Right? Yes. Awesomeness. Awesomeness. So keep these formulas also in mind. Keep these formulas also in mind. So, say for example, I tell you, a particle has angular acceleration of 20 pi radians per second square and tangential acceleration of 2 radians, 2 meters per second square. Find the radius of the circle. Find the radius of the circle. How do you do this particular question? The particle has angular acceleration of 20 pi radians per second square. That means this value over here, what is that? That is alpha. 2 meters per second square is the tangential acceleration clearly mentioned. That means that is AT. So the formula that we need to use is AT is equal to alpha into R. AT is 2, alpha is 20 pi, R is unknown. So 2 cancels. Rather, it will be 2 by 20 pi. So it will be basically 1 by 10 pi. So 1 by 10 pi meters is the answer. 1 by 10 pi meters is the answer. How many of you wrote this? How many of you wrote this 1 by 10 pi? If you wrote 1 by 10 pi, very, very happy. So if you have understood all the basic terms, what is rotation, what is translation, what is omega, what is alpha, what is tangential acceleration, what is tangential velocity, very good. And if you understood it till here, put a thumbs up in the chat box as well. Now let's move on to rotation. Rotation of moment of inertia. Very, very important concept. This will be used at many places. Solo questions may also come, but usually used in different places. Get ready. Call all your friends who used to crib or who used to say, hey, you know what, Macha, I never understood rotation. Tell them Shreyas sir is live. Put this link, channel link, the video link in your Telegram groups or WhatsApp groups or study groups, Discord servers, status, whatever. If you want, you can tag me also, Captain Shreyas. That's all my handle. Be it Telegram, be it Instagram. Okay. So what is this moment of inertia? Okay. So imagine what happens is there is one champa over here. Beautiful. And Pandu has to push that champa. Maybe there is a skating competition or whatever. So Pandu has to push the champa. Now, if champa's mass is more, heavy champa is there, won't Pandu find it difficult to get to the same speed? If Pandu has been given a target, you have to reach 10 meters per second speed, then to reach that speed, won't it be difficult? If mass is more, it is more difficult to change the state, basically the state of motion. And that's when we say the champa has more inertia, correct? But this inertia is of translatory motion. Yep. Now what happens in another competition, another day, champa has to be rotated. Like a nice dance, like how it happens in Bollywood movies. See how her hair is nicely flying over here. Okay. And this is your Pandu maybe. Okay. Something like this. Oops. This is your Pandu. And Pandu is rotating champa. Look at this. Such a beautiful couple. Pandu is rotating champa. Now tell me one thing. Pandu will again face some resistance to rotate her. Will face some resistance to rotate her. And that difficulty to rotate, which is also called as the resistance to change, the state of not just motion, rotational motion. That is not the inertia of translation, that is the inertia of rotation. Moment is also another word for rotation. So it is called as the moment of inertia. Moment of inertia. Now what do you think does this moment of inertia depend on? Let's see if you all Pandus and Champas can answer this question correctly. What and all do you think it will depend on? Do you think it will depend on Champa's mass? Do you think it will depend on Champa's mass? Think about it. Do you think it will depend on Champa's mass? Heavy Champa is there, bulky Champa. One is 60 kg Champa, one is 30 kg Champa. 30 kg Champa versus 60 kg Champa, more difficult to rotate the 60 kg Champa, yes or no? Yes, very good. So can I say that the moment of inertia depends on number one, 100% the mass of the body. Very good. Next thing, imagine there is one slim looking Champa versus a broad Champa. Slim looking Champa versus a broad Champa. Mass are the same. Sometimes some girls are thin, right? Very long, very tall. And then some person will be very short and very wide. Have you seen those kind of people? So who do you think will be more difficult? That slender Champa versus the wide Champa. Masses are same. 30 kg, 30 kg. One is thin Champa, one is wide Champa. Whom do you think will be more difficult? Pandu team captain, Champa team captain of NEET Warriors. Yes, Yashwant. Yes, your captain Shreyas. Yeah, it definitely is going to be difficult to rotate that wide Champa, yes or no? So what does it depend on? How close or far the masses are from the axis. How close the masses are from the axis. That means it depends on where the masses are, that is distribution of the mass with respect to the axis. Keep this in mind. Yep. There is one more thing which it depends on. If Champa is rotating about this axis, it will be completely different. If Champa is rotating, let's say about this axis over here, the hand is here, imagine this, and Champa is rotating like this. The hand is here, that is the axis, and the Champa is rotating like this. Then the axis is here. Versus the axis is passing through her. That means Champa is rotating like this. Don't you get that feeling that it is going to be difficult to rotate when the axis is little bit far away from the body versus the axis is passing through the center of mass? If the axis is passing through the center of mass, then I think it will be easy to rotate. But if the axis is somewhere here, then imagine to rotate the Champa will be more difficult. Yes or no? Yes or no? Yes. So what does it also depend on? The axis of rotation. The axis of rotation. Keep this in mind. Very good. Excellent. So going ahead, my dear students, what is the formula of moment of inertia? I just told you what does it depend on. What is the formula now? The formula of moment of inertia is something like this. If, say for example, this is your axis of rotation, and maybe there is a particle here, This is at a distance of r1. It is going in a circle like this. Maybe there is another particle over here, m2, that is at a distance of, let's say, r2. It is going like this. Maybe another particle somewhere over here, let's say r3, having mass m3, going like this. Maybe somewhere over here, like that, some more particles, okay, and many such more particles here and there. They are all rotating about the axis. Try to visualize. They are all rotating about the axis. Try to visualize. The moment of inertia formula is given by mass 1 r1 square plus mass 2 r2 square, like that till the n terms, which you can simplify and write it as sigma. Sigma is the symbol for summation or adding similar terms. So mi ri square. Mi ri square. So that is the formula for moment of inertia. Mi ri square summation. Yes, very good. But this is okay when the particles are discrete. Particles are separate. This is called as discrete mass system. Discrete mass system. That means they are particles. That means there are particles which are rotating. Sometimes you might not have particles. You might have some continuous body. Maybe this is the axis about which it is rotating. This is the axis about which it is rotating. This is a continuous body. In that case, you take small masses on that body. Each mass is a dm. Dm is an elemental mass. Dm is an elemental mass on that body, a small mass, and it is at some distance r from it. R is the distance from the axis. It is the distance of that dm from the axis. Then the moment of inertia, instead of sigma, what will come? Integration. Instead of m1, m2, m3, what will come? dm. And r will be the general variable. So it will be integration of r square dm. Integration of r square dm. So this is the formula which comes if it is a continuous body. Very good. Everybody understanding it till this point? Cool. Now let's see, if I ask you a simple question, easy question, can you spam the answer or not? What will be the SI unit of moment of inertia? What will be the SI unit of moment of inertia? Come on, my dear students. What will be the SI unit? Look at the formula. You will get the answer very easily. The formula of moment of inertia is mi ri square. That means mass into r square. So the unit will be nothing but kg meter square, or in CGS unit it will be gram centimeter square. Very good. Kg meter square or gram centimeter square. Very nice. So that is the unit of moment of inertia. Let's solve a simple question, then we will go ahead. Today's session, I am going to take all the, you will see the in-text questions as well. I will take the back exercise as well. And some of you have already watched my logic gates class. So you will see that apart from NCERT, there will be PYQs also. So PYQs, NCERT, in-text, back exercise, all the summary points which will be covered as theory, which I am giving you as PDF notes. Again, it's going to be available in the Telegram channel. Remember that. So pay attention carefully. Say for example, there is a mass here of 2 kg and here there is a mass of 3 kg and this is the axis, and let's say this is the axis, okay, about which it rotates, and let's say this is 4 meters and let's say this is 6 meters. Question is, find the moment of inertia. Find the moment of inertia. 2 kg here, 3 kg here, they are both rotating like this. They are both rotating like this. Try to answer the question, what is the total moment of inertia? Come on, my dear students. Come on, my dear students. Let's try to solve the question. What is the formula for moment of inertia? The formula is m1 r1 square plus m2 r2 square plus m3 r3 square. But here there are two particles. So I think we can end with two terms. There is no need of third term. There is no need of third term. Very good. Some of you have already posted the answer. You are very bright students. So m1, if I take it as 2, r is basically 6 plus m2 is basically 3, r is basically 4. Correct? So 6 square 36. 6 square 36. 36 into 2, 72. 4 square 16. And into 3, which is nothing but 48. I see many people gave the wrong answer. I see many people gave the wrong answer. Yes, be careful guys. Some of you wrote the answer as 24. How will the answer be 24? Think carefully. How will the answer be 24? What mistake did you make? Where did you go wrong? I think you forgot to square. Yeah, I think you wrote 12. 3 4s are 12. 2 6 are 12. 12 plus 12, 24. You forgot to square, no? Yeah, correct. So the answer will be 120 kg meter square. So that's why we start with easy problems and slowly scale it up. Once you understand what mistake you are making in easy questions, it's easier to solve average and PYQs and difficult questions. Very good. Very good, my dear students. Let's move ahead. Let's move ahead to the next question, okay, which is coming up on your screen. There is, let's say, a particle of mass m, and it is having some distance from the axis. If I rotate it clockwise versus if I rotate it anti-clockwise, whose moment of inertia will be more? In which case will it be more? Clockwise will be more or anti-clockwise will be more? What do you think? Clockwise will be more or anti-clockwise will be more? Very easy peasy lemon squeezy question. Yep, think. Does that matter whether you rotate clockwise or anti-clockwise? Definitely not. So the answer for this question is just a big equal to. It's just a big equal to. It does not depend on the speed. No, some of you are saying clock or something. No, it is not going to be dependent. Very good, Janice. Yes, crazy. Yes, very good. No, Yashwant, it is not anti-clockwise. Very good, Alam. Very good, Rushika. Very good, Sidhu. Yes, Suchi Mama. It is going to be equal. Now, are we required to solve the integration part for all the geometries? Answer is no. For NEET, you just need to remember that via integration, this one, you get the moment of inertia for different geometries. So what are those geometries? Let's have a look. What are those geometries? Let's have a look. First one is a ring. First one is basically a ring, and this is the axis. This is the axis. Okay. So if the ring has certain radius r and mass m, then about that central axis, the moment of inertia of the ring is nothing but mr square. That's all. It is simply put mr square. Remember this formula. This is for a ring. Similarly, if you take a disc, okay, so disc means it is fully solid. It's like a cookie or a biscuit, Mari biscuit. It's like a Mari biscuit. Ring example will be like a bangle, correct? A bangle, or a cycle tire without the spokes. The cycle tire without the spokes. It's like a ring. Whereas disc is like your biscuit or a flywheel. All these are basically examples of disc, correct? And then again, this is the axis of rotation. This is the axis of rotation. Mass is m, radius is r. The moment of inertia formula is mr square but by 2. Mr square, but it is by 2. Mr square by 2. Very, very important. Keep this in mind. Then the next geometry which you need to remember, is a rod. Whenever you are bored in the class, how many of you do this with your pen? How many of you do this with your pen? I don't know whether you can see this. It's like a rod, right? It's like a rod, and you hold it here, and this is the rotational axis. This is the rotational axis, correct? So rod, when you rotate it about its central axis. So this is your rod. This is your rod over here, and this is the axis about which you are trying to rotate it. The rod has a mass of m, and remember the total length of the rod is L. Total length of the rod is L. Then the moment of inertia formula after integration is ml square divided by 12. ml square divided by 12. Again, something which you should be aware of. Yes, Krutuja always does that, Janice always does that, Krishna also does that, Notes also does that, Avantika, everybody is normal student over here. All students are normal. Very good. Next geometry is hollow sphere. Hollow sphere. Hollow sphere. What is the meaning of hollow sphere? That means inside nothing is there, only the shell part is there. Only basically the shell is there, inside is empty. In such a case, if the mass is m and if I tell you the radius is basically r, then the moment of inertia formula is 2/3 mr square. 2/3 mr square. Keep this number in mind, 2/3. Everybody with me? 2/3 mr square. Very good. Next, solid sphere. Solid sphere. Solid sphere. Solid sphere. So it is completely filled inside, like earth or a cricket ball, right? A plastic ball might be empty inside, so it's like a hollow sphere or a shell, but a solid sphere is completely filled. So this is your axis, and in that case the moment of inertia is 2/5 of mr square. 2/5 of mr square. You need to remember all of this. With practice you will remember these numbers. Only this number changes. Solid is 2/5, hollow is 2/3, rod is 1/12. Instead of r there is L over there. Disc is 1/2, and ring there is no number, only it's just 1. But I'll tell you, there are two more additional geometries. One is hollow cylinder and solid cylinder. But guess what? When you have a hollow cylinder, this is basically a hollow cylinder. Hollow cylinder is just like stretching this ring. Are you able to visualize this? You take that ring, imagine it to be stretched along the axis, you pull it, elongate it. Won't you get the hollow cylinder? The formula remains the same. In fact, that's the property of moment of inertia. You can just stretch things and you will see the moment of inertia will remain the same. Correct. Very good. Very good. So for a disc, if you elongate it, my dear students, what you will get is nothing but a solid cylinder. Solid cylinder. It's completely solid. It is completely solid. Keep this in mind. It's full. It's not empty inside. So that is nothing but your solid cylinder. Solid cylinder also has the same formula as a disc. So it is mr square divided by 2. Mr square by 2. Yes. Very good. So that's the rod, that's the hollow sphere, and that's the solid sphere. And we have to go to problems. But before going to problems, there are two important things which I need to tell you, and that is, how do I find the moment of inertia about some other geometry? How do I find the moment of inertia about some other, not geometry, other axis? There are two transformational theorems which you need to remember. With that, you can find it about certain other axis. So let's try to see those transformational theorems. The first theorem being parallel axis theorem. Parallel axis theorem. This is used to shift the axis, used to find the moment of inertia about some new axis. So say for example, there is a body over here. This is the center of mass, and it so happens that about the center of mass, when you rotate it, you know the moment of inertia to be ICOM. You know the moment of inertia to be ICOM. Now, you want to find the moment of inertia about an axis which is parallel, and let's say the distance by which you have shifted it is d. You shift the axis by a distance of d from the center of mass. Parallel axis. This axis can be outside, can be inside. Both are possible. This could be outside or even inside the body. And in the diagram I have shown it outside, but you could have drawn it inside. There is no harm in that. Then in such a case, the moment of inertia about the parallel axis, you can see this is a parallel axis. This is parallel axis is equal to, you first write down moment of inertia about center of mass, and then you write down plus mass of the body into the distance by which you shifted. So md square. Mass into distance by which you shifted it, square it. That is the new moment of inertia. Necessarily, the axis initially should be at the center of mass. Necessarily, the next axis must be parallel to the center of mass axis. Otherwise, you cannot use it. ICOM plus md square. Just to give you an example of this theorem, let's say, my dear students, this is your solid sphere. This is your basically solid sphere. Okay, and I want to rotate it. About a tangential axis. And that is exactly the question. How much is the moment of inertia? So what I will do is, I'll realize that I don't know MOI for this axis, but for solid sphere, I know it about the central axis. So what I will do, if I just draw a line like this, this is the axis passing through the center of mass, and about the center of mass, the moment of inertia is 2 by 5 mr square. How much did I shift it by? Come on, my dear warriors. Answer in the chat box. How much is the shift? Yes, the shift is basically r. Shift is basically the radius itself from here to here. Parallel axis. So the new moment of inertia, which is ICOM plus md square. ICOM will be 2 by 5 mr square. D is basically r. So won't it be 5 plus 2 is 7. So 7 by 5 mr square. That is the new moment of inertia. How many of you understood how to use this theorem? Did you understand how to use this parallel axis theorem, my dear warriors? Very good, if you understood it. Very good. Excellent. Let's go to the next theorem. And the next theorem is basically, there will be more examples which I'll be taking. Don't worry. Like, sir, only one example. Chill, Madi. I'm going to give you more examples. So, perpendicular axis theorem. Just like the name suggests, something will be perpendicular. Okay. So, first draw a laminar body. This is only applicable for laminar body. Laminar means it's only there as a sheet or in 2 dimensions. Which are the examples of laminar body? Which are the examples of laminar body? Come on, my dear students. Come on, my dear students. What are some of the examples of laminar bodies? Can I say this book over here is almost like a laminar body? This book over here is almost like a laminar body. Yes, very good. What about this? Is this jar a laminar body? Is this jar a laminar body? Of course, it's a 3-dimensional body. It's not like a sheet. It is non-laminar body. It's non-laminar body. Correct. Your carpet is laminar. Square, disc, ring are laminar. Sphere are non-laminar. Pyramid, non-laminar. Very good. Awesome. Many of you understood what is laminar. So, only for laminar. But parallel, there is no such condition. You can use it for laminar, non-laminar. There is no such restriction. Restriction is only there for this theorem. Immediately what you do is draw two axes which are in that plane. Draw two axes which are in that plane and also perpendicular. I call the moment of inertia about this axis as I1. Call the moment of inertia about this axis as I2. So what I am doing is calling the moment of inertia about one of these axes as I1 and another axis as I2. Where are I1 and I2? In the plane. If this is the plane, it is in the plane, and also they are perpendicular. So keep this in mind. They are perpendicular and they are in that plane. Now you just add I1 and I2. What you will get is, if you draw another line which is basically perpendicular to both of them, then about this, if the moment of inertia is I, then that will be basically I. So I will be I1 plus I2. You can say it is perpendicular to both of them. So that is why it is called perpendicular axis theorem. Everybody understood? Oh? Clear? Oh? Yes, for rectangle also you can use it. Shall we take an example on this so that you understand how to use it? Okay. Let's say we take a disk. Basically a disk. If I draw an axis which is, let's say, like this, okay, or let's say it is like this, or let's say it is like this, or like this, or like this. Tell me, are all the axes identical or not? Whether I rotate it like this, or whether I rotate it like this, or 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 like this. Tell me, are all the axes identical or not? First tell me that. Then we will proceed with the problem. If you say yes, then we will see what to do. If you say no, then we will see what to do. Try to visualize. Take a coin, take a sheet, take a disc, take a biscuit, Marie biscuit, and try to rotate it like this or like this. It's one and the same thing. So all the axes are identical. So how about I want to find out the moment of inertia. When I rotate it about this particular axis. This is what I want to find. So what I will do is, I will think, wait a minute, I don't know the formula for the moment of inertia of a disk about the diametrical axis, but what I know is the central axis moment of inertia formula. About this axis I know. And how much is it? How much is the formula for this axis? It is nothing but mr square by 2. Okay. I think I might need one more axis to apply perpendicular axis theorem. Because for applying perpendicular axis theorem, 1, 2, 3. 1, 2 and 3. Two of them are in the plane. One is out of the plane. Two are in the plane. One is out of the plane. So one is out of the plane. You can see mr square by 2. It is out of the plane. We need one more axis in the plane. So where do I draw it? Draw it perpendicular. Draw it perpendicular. So this is that axis which is basically perpendicular. Is that seen? Now if this is I, what will be the moment of inertia for this axis? Same. So won't this also be I only? Won't this also be I only? Everybody with me on this? Very good, very good, awesome. And are you seeing the out of the plane axis is perpendicular to this also and this also? So using perpendicular axis theorem, the perpendicular one, which is mr square by 2, won't it be equal to this I plus this I? Therefore, it will nothing but be 2 times of I. Therefore, I will be, take 2 below, won't it be mr square by 4? Won't it be mr square by 4 about the diameter? Understood or clear or? Everybody with me? Everybody with me? Understood what we just did? We took this additional axis because it was in the plane and perpendicular, and I know whether I take this, all diameters are same. So if this is I, this will also be I. So I plus I will be perpendicular moment of inertia. Perpendicular axis theorem done. Very good. Awesomeness. Great. Kudos. So now that you understand both these theorems, we'll be applying it in different problems and seeing what the results are. But there is one more thing which you need to know. Very rarely some stupid question will come on that, and that is radius of gyration. And that is radius of gyration. Radius of gyration. Radius of gyration. So my dear students, for radius of gyration, what you need to know, the concept is, if you have some rigid body and you rotate it and you find that the moment of inertia is I, let's say the mass is m, you melt this body and convert it into a point mass. You will have to put it at some distance such that it has the same moment of inertia as before. You will have to put it at certain distance so that it has the same moment of inertia as before. That distance for which the moment of inertia is the same is called as the radius of gyration k. Is called as the radius of gyration k. So you have a solid sphere, it has some moment of inertia, some resistance to motion. You melt it, write it into a point, connect it into a point, and then place it at some distance so that it behaves same way as this. That distance is called radius of gyration. So over here, I will be mass into distance square, so mk square. As simple as that. That is the moment of inertia relation with radius of gyration. Just to give an example, find the radius of gyration for a hollow sphere. Let's see how many of you can do this. Find the radius of gyration for a hollow sphere. What do we do? Okay, use the formula. I is equal to mk square. For a hollow sphere, what is the formula for I? It is 2/3 mr square. So this will be equal to mk square. cancels. So k square will be r square into 2/3. So k will be r root of 2/3. That is the answer. R root of 2/3. Very good. Awesomeness. Next important for a question on this only. If a body of mass 10 kg has a radius of gyration 4 meters, then its moment of inertia is how much? Come on, my dear students. The radius of gyration is given, the mass is given, find the moment of inertia. Again use the formula. I is equal to mk square. What and all is given? Mass of the body is given, 10. Is the radius of gyration given? Yes, it is 4. So 4 square. 4 square is 16. 16 into 10, 160. 160 kg meter square is the moment of inertia. Great. Very good Varsha. Very good Rishika. Very good Sanvi. Very good Shreya. Excellente. Very good Shiva. Very good. Are you ready for some objective questions coming along the way? Here is the first question. Start answering it. The moment of inertia of a body does not depend on mass, angular velocity, axis, distribution. We just saw the theory. If you remember it or go back a little, you will know which of the options are wrong or correct. Does it depend on the mass of the body? Yes. Does it depend on the axis of rotation or angular velocity? Well, angular velocity, no. Axis, yes. Distribution, yes. So the incorrect option will be B. So answer is B, I believe. Very good. B for bananas. Very good, Alam. Very good, Kailash. Very good, Selvan. Very good, Krishna. Very good, Sanvi. Very good, Rutuja. Very good run. Excellent, my dear warriors. Keep it up. And if you are new to the channel, subscribe first of all. And if you have already subscribed, then smash the like button. Show your love. Show your support for your captain for these sessions, because very few channels are there in English and quality content is right over here only. A closed tube partially filled with water lies in a horizontal plane. If the tube is rotated about the perpendicular bisector, the moment of inertia will increase, decrease, remain same, depends on how you rotate, clock or anti-clock. There is a closed tube. There is a closed tube and this is the axis. There was some liquid over here. There was some liquid over here. And you rotate it. So what do you think will happen because of this? Because of this, if you rotate it, what do you think will happen? 100% the liquid won't stay there. The liquid will collect towards the ends, right? The liquid will go towards the ends, right? So what has happened? The mass has gone far away. That means R has increased. R has increased. That means moment of inertia will also increase. Hence the answer should be A for Ames. How many of you wrote A for Ames? No, it is not. C. Many of you thought it will be constant. But think again, the mass will go far away. So the R values, M1 R1 square, R1 will increase, R2 will increase, R3 will increase. All the R's will increase. So that's why the moment of inertia will also increase. Very tricky question this is. Very tricky question. Yes, awesome. Let's move on to the next one. The moment of inertia of a solid cylinder of mass m, radius r and length l about the axis is. Come on, this is standard. Just checking the formula. If you know the formula, you can easily get it. You can easily get it. Come on, come on, come on. Let's see how many of you remember that formula. The moment of inertia of a solid cylinder. Solid cylinder, I just told you, is like a disc. And for a disc, the formula is what? Mr square by 2. Is it D for doctor? Yes, D for doctor it is. Very good. So I told you that property, a ring can be made into a hollow cylinder, a disc can be made into a solid cylinder. So disc is Mr square by 2. So solid cylinder will also have the same formula. Very nice. Two discs are having mass 1:2, diameter 2:1. Ratio of the moment of inertia, Jipmer question. Ratio of the moment of inertia, Jipmer question. Come on, my dear students. Jipmer question. Two discs having mass and diameter in the ratio of this and this. So one thing I know, M1 by M2 is 1:2. D1 by D2 is 2:1. But diameter is radius into 2. So if D1 by D2 is 2:1, therefore R1 by R2 is also going to be 2:1. Correct? Diameter is twice the radius. Each diameter is twice 2. 2 cancels. Okay. Another thing which you should note is moment of inertia is proportional to mass into radius square. Number constant will change, but it is proportional to that. So I1 by I2 will be M1 by M2 into R1 by R2 whole square. M1 by M2, 1 by 2. R1 by R2, it is 2 by 1. So 2 by 1 whole square is 4. 4 by 2 is 2. So 2 is to 1. 2 is to 1. Is it there? Ames? Is it there? Ames? Yes. Ames is the answer, Janice. Very good. Very good. Very good. Ritika. Very good, Alam. Very good, crazy dude. Yes, Shivani. The answer is Ames. Perfecto. Perfecto. Moving on to the next question. There is one solid sphere and another hollow sphere. Both are having same mass, same outer radii. Their moment of inertia about their diameters are IA and IB, solid and hollow. Their outer radius are the same. So one is hollow, one is solid. One is hollow, one is solid. Think about it carefully. One is hollow, one is solid. The formula for hollow is 2/3 mr square. And for solid, sphere A is solid. So this is 2 by 5 mr square. This is A, this is B. Who is more, 2/3 or 2/5? Obviously 2/3 is more. 2/3 is more. So IA will be less than IB. IA will be less than IB. Yes, very good, my dear students. They both are not equal. IA will be less than IB. This was A, which was solid. B is hollow. So 2/3 is 0.66, 2/5 guys is 0.4. So 0.66 is more than 0.4. So 100% IA will be, less than your IB. IA will be less than your IB. Is that clear? Very good. Option C is the correct answer. Excellent, my dear students. Keep it up. Next question on your screen, NEET 2021. I'll give you some time. You can take a pause and start solving the question. From a circular mass or ring of mass M, radius R, you take out a sector of 90 degree. A big ring is there. You take out 90 degree from it. The moment of inertia of the remaining part about an axis through the center perpendicular to the plane is some number of times of mr square. What is that number of times it is? Try to visualize the question. First, the ring was complete. Now the ring is basically going to be just 3/4. Now the ring is just going to be 3/4 because you have taken 1/4 part or 90 degrees out of it. Earlier, when it was complete, the moment of inertia was mr square. Earlier it was mr square. Now I feel about this axis, it won't be mr square. Think about it. Think about it. What will it be? Think about it. What will it be, my dear students? Okay, here is one thing. Mass will be different, but radius will be same. Correct? And also think this way. If you add this part back, you will get back this moment of inertia. You will get back the original ring. Each part which was there, how many parts? There were 4 parts, right? Each part which was there, each part, how much contribution they will be having? It will be having mr square by 4. mr square by 4. Each part, mr square by 4, mr square by 4, mr square by 4. So that's how you get the ring. So if there are 3 parts, think about it. Over here, if there are 3 such parts, how many times of mr square by 4? 3 times of mr square by 4. So the number should be 3/4, right? So the number should be 3/4 of mr square. It is k times of mr square. That k is basically 3/4 times of mr square. So this is basically your k. So hence the answer should be 3/4, option C. How many of you wrote C for Captain Shreyas? Very good, very good, very good. Excellent. Moving on to the next question on your screen. Okay. After this questions, we are again going to come back to theory. The moment of inertia of the straight thin rod of mass m, length L, about an axis perpendicular to its length and passing through one of its end. Passing through one of its end is how much? Very interesting question. Come on, my dear students, some theorem will be needed. Of a straight thin rod is there about an axis perpendicular to the length and passing through the end. That means this. This is the axis, guys. This is the axis about which you have to calculate. This is the axis about which you have to calculate. So think about it. If you rotate it like that about the end and you want to find the moment of inertia about that axis, I feel we should draw one more axis right over here, which is passing right through the center of mass, and the formula is ml square by 12. ml square by 12 about that particular axis. This is parallel to that, and I'm shifting it parallelly, but by how much distance? Let's see how many of you can answer this. What's the difference between these 2 points? How much distance did I shift it by? Yes, it was L by 2. So about the parallel axis, moment of inertia about the parallel axis will be about center of mass is ml square by 12 plus how much is the shift? L by 2. So ml by 2 whole square. So do the math now. ml square by 12 plus ml square by 4. LCM is 12. So ml square plus 3 ml square, which is 4 ml square by 12. 4 by 12 is 1/3. So 1 by 3 ml square. That's the moment of inertia about that parallel axis at the end. At the end. Correct. That is the correct answer. That is the correct answer. Very good. Very good. Keep it up, my dear students. Keep it up. Awesome. I'm seeing all your answers. I'm seeing all your answers right away. Very good. Some of you are very quick. Some of you are understanding it as I explain. Yep. Definitely, Bala Murugan, I will tell you very soon about the courses. Hold on. Okay. Right now, this is a NEET channel, so I can't tell you here. Okay. Cool. Moving on. Next question. Moment of inertia of a circular wire of mass m, radius r. That means a ring. Circular wire of mass m and radius r means basically a ring. Okay. About its diameter. I think we have done this kind of a question. If you have a ring and we are talking about the diameter and I want to find the moment of inertia, why not draw another diameter which is also perpendicular that will also have the same moment of inertia? And if I draw perpendicular to both and about that axis, I already know it is mr square. And that axis is perpendicular to this also and this also. So using perpendicular axis theorem, what will I write? Mr square. This one is this plus this. So I plus I, which is 2I. So I will be mr square by 2. mr square by 2. Perfect. If it was a disk, I think this will be mr square by 4. If it is a disk, it will be mr square by 4. Yes, Ames is the correct answer. Very good. Congratulations. Congratulations. Next question on your screen. One step closer to your NEET 2024. Every question that you answer is getting you one step closer. If you miss the class, you have missed some steps. You are behind. But all the students who are watching it live or recorded, they have crossed at least 100, 200 or 300 steps in one lecture. So you decide when you decide to miss a class, you want to fall back or not. If you want to fall back, don't attend. If you want to go ahead, please attend the classes because Shreyas sir is leading your way. Your captain Shreyas. Next question. Moment of inertia of a ring about a tangent in its plane. About a tangent in its plane. Interesting. So let's try to draw this. This is the ring. Tangent in its plane, meaning something like this. I want to rotate it like this. Oops, how do I do that? Maybe I know about some parallel axis. Maybe I know about some parallel axis. Look at this. This is center of mass. And now I just have to shift it. I just have to shift it. By how much do I have to shift it? I think it is r. I think it is r. This is the moment of inertia about the tangential axis. This is the moment of inertia about the center of mass axis. Oh, but I don't know the moment of inertia about this axis. But I think I found that out in the previous problem. I found that out in the previous problem about this yellow axis, I found it out to be mr square by 2. For a circular ring, I found it out to be mr square by 2. So by drawing basically two diameters, this is also ICM. So using perpendicular axis theorem in the previous question, ICM was mr square by 2. Is that right? It was mr square by 2. Now from here I will find it for this guy using parallel axis theorem. So use parallel axis theorem. So I tangential will be moment of inertia about center of mass plus m into the shift square. About center of mass, it is mr square by 2 plus mr square. 1 by 2 plus 1 is 3 by 2. So 3 by 2 mr square. 3 by 2 is C for Captain Shreyas. Yes, that's the correct one. How many of you wrote it? Yes, C for Captain is the correct one. Very good. Proud of all of you. Proud of all of you. Yes, that's the correct one. Amazing, right? So there are some problems which involve perpendicular as well as parallel. This is one such question. And I'm making you solve and realize how to solve all patterns of question. If you are attending class today, you are learning different patterns of question, and every pattern is next level higher than the previous pattern. Slowly I'm increasing the difficulty and you are getting a hang of the questions. Moment of inertia of a circular disc, about the diameter is I. Moment of inertia about an axis perpendicular to the plane and on the rim will be how many times of I? C for Champa, C for Capto. Oh my god, I think you guys will pakka make Pandu angry. If Pandu finds out C for Capto, C for Champa, Pandu will be like, what is happening? What about me? Pandu will be angry. Be careful. Moment of inertia of uniform circular disc about diameter is I. Okay, this is your disc. And about a diameter. Diameter means this again. Now both the diameters have the same moment of inertia. Both the diameters have the same moment of inertia. And if I take this axis, if I take this central axis, it would be mr square divided by 2. Mr square divided by 2. So if I happen to use perpendicular axis theorem, then mr square by 2 will be I plus I, which is basically 2I. Therefore, I will be mr square divided by 4. That's the value of I, which I found out about the diameter. All the diameters which I show will have the same inertia, right? Correct. See, Pandu is already angry over here. Pandu is feeling sad. Just like it happens in Bollywood. One heroine gets linked with other hero, that other hero will get angry. Then the heroine will tell some statement. Then this hero will also get angry. Then controversy happens. Now, the next thing, axis perpendicular to the plane and passing through the point on its rim. So, in the other case, where you have that disc, axis perpendicular to the plane and passing through a point on its rim. This is the rim, and perpendicular to the plane means it is like this. Means it is basically like this. Check this out. This is the axis, and 100% it is parallel to this axis. Parallel to this axis, which is having mr square by 2 moment of inertia. Clearly, this is a parallel axis which has been shifted by r. So this will, according to parallel axis theorem, parallel axis theorem, this will be mr square by 2 plus m into shift square, which will be 3 by 2 mr square. Now, how many times of this is this one? Well, we can do one thing. Over here. Mr square, check this out. Mr square is basically 4 times of I. Mr square is basically 4 times of I. So replace this with 4i. Replace this with 4i. What will happen? 4 and 2 cancels. 2 remains. 2 3s are 6. So 6 times of I. So 6i is capped in Shreyas. Yes, Capto is the answer, or Champa is the answer. Very good. Very good. Very good. Awesomeness. Proud of all of you, my dear NEET aspirants. Trust me, if you have attended till here right now, you have taken the first big jump, long jump, I would say, without any hurdles, just by attending this class in moment of inertia. You have really nailed it, and you should be proud that till now, whatever you learned, it's gone into your head. Now, what you need to do? You need to revise after this lecture also, okay? Let's go to the next concept now. Are you warriors ready for torque and angular acceleration? For torque and angular acceleration. Ready for it? How to find the torque? How do I relate it to angular acceleration? What about pulleys with masses? What about equilibrium problems? All those things over here right now. Let's get ready for it. Perfecto. Now, listen. Remember, Champa, she was pushed by Pandu. She was pushed by Pandu, and she started to skate. She started to move on the ground some time back. So there was a push. This Champa had some inertia, and because of that, she basically accelerated, or she went into motion, right? Now, can I write like this? Force is equal to mass into acceleration. This is your Newton's law. This force is that push which is the cause of the motion. This m is the inertia of the body. This a is basically the effect. So, effect into inertia is the cause. Is that right? Everybody with me? So, when you translate, when you move, when you push something, that force is the cause, and depending on how heavy or how light, it will accelerate. If it is light, it will accelerate more. If it is very heavy, like an elephant, then it will accelerate less. So, now, if this Champa has to be rotated, look at this beautiful Champa. This Champa has to be rotated, and there is a Pandu beside her. Who is pushing her, who is trying to rotate her, about this particular axis. I feel that now you will have a rotational cause. You will have a rotational cause. Instead of inertia, you will have rotational inertia, which is nothing but moment of inertia. And the effect, what do you think the effect will be? Come on, put it up in the chat box. What do you think the effect will be? Put it up in the chat box. Come on. What do you think will be the effect? Put it up in the chat box. 100% it will be angular acceleration. Basically, it is the rotational effect. Rotational effect, which is angular acceleration. So, moment of inertia is I. Rotational effect is nothing but alpha, and rotational cause is called as torque. What is this called, my dear students? This is like force, but in rotation, it is called as torque. It is the cause of the rotation. Pandu rotated Champa, he pushed her at an angle, he propelled her like this, he was rotating, taking her arm and rotating, or maybe he was holding her shoulders and rotating. So that is the rotational cause, and that cause will determine how much the acceleration is, and it also depends on how heavy Champa is, where is the axis, how far is the mass distribution, that is moment of inertia. Yep. So torque is equal to I alpha, perfecto. So this is a very famous equation, and if you write it in vector form, whatever is the vector of torque is the same direction for alpha also. If you accelerate her like this, torque will also be clockwise or anti-clockwise. Okay. So whatever direction is the torque, same direction alpha. This is your Newton's law in translation. This is your Newton's second law in rotation. Let me remind you of that. So this is Newton's laws of motion in translation. In translation, keep this in mind. But this one is nothing but your Newton's law of motion in rotation. In nothing but rotation. Keep this in mind. Very good. Now you might be wondering, sir, how do I find out this torque, sir? How do I find out this torque, sir? Yes, there is a formula. If you apply a force at certain distance, then you will see you will be generating a torque. Let's see certain examples where you can and where you might not generate a torque. Imagine this is a door. Imagine this is a door. I will show different orientations of that door. Okay, this is your axis or that hinge about which that door or that window can rotate. Okay, let's say somebody pulls the door like this, applies the force like this. Somebody applies the force like this. Okay, somebody applies the force here. Somebody applies the force here. Somebody applies it at an angle. Somebody applies the force at an angle. In which all situations do you think? In which all situations do you think that there will be torque? In which all situations do you think that there will be some kind of a torque? Come on, think about it. Here you are applying it at that hinge only. Okay, I'm showing you where you are applying it with this yellow dot. With this yellow dot over here. Where are you applying that force? Come on, in the first situation, what do you suggest? Will there be torque? Yes or no? Will there be torque? Yes or no? In the first situation, come on, think about it. Try to visualize this. Try to visualize this, you will get the answer. Try to visualize. Imagine a door and somebody is pulling that door in that same direction. I mean, really? Think about it, my dear students. Think about it, my dear students. This door is there. This door which can go like this. And I'm pulling that door here. How will it rotate? Imagine it's like I'm pulling it like this. I'm applying the force like this. I need to either push it here or push it there, right? Only then it will rotate. So if I'm pulling it like this, how will it rotate? No, right? So there is no torque. Torque is basically zero. No torque. What about this scenario? What about this scenario, my dear warriors? Think about it. What about this scenario? Think about it. Will there be torque? Yeah, there is a hinge here on this side and you are pulling it or pushing it here. So 100%, you can visualize it. It will definitely rotate. So there will be torque. There will be torque definitely over here. The torque will try to rotate it like this, correct? It will try to rotate it like this. Definitely there will be a torque here. It is basically perpendicular. Think of it like this. It's somewhat like that. Visualize it in 3 dimension. Maybe in 2 dimension figures it is little complicated to understand, but visualize this in 3D. Yeah. So this is that door and somebody has pushed it here. Somebody has pushed it here. So like this. Somebody has pushed it here. So definitely that perpendicular force, look at my pointing finger, it has definitely opened that door. If you apply the force here, this is the hinge. Remember, this is the hinge, this pen axis is the hinge. Okay, if you apply the force exactly at the hinge, what will happen? Nothing will happen. The torque will be basically a zero. There will be no torque at all. The torque will be zero. No cause at all. No cause at all. Correct? Everybody? Check this out. Definitely there will be no torque at all. What about, I think I showed the same case over here. My bad. But I wanted to show an angle in this case. It is at an angle over here. It is not exactly perpendicular. Do you think still it will open up? Do you think still it will open up? Will the door open up or rotate, or what do you think? Will it happen or no? Think about it. I feel it will, because you can try it yourself. If this is the door, and if you are applying it at an angle, apply the force at an angle. See, apply the force. Try to apply the force at an angle. Try to apply the force at an angle like this. Try to apply it at an angle. 100% it will open up, but not as much as this much. So there is definitely some kind of torque over here. So definitely there is some kind of torque over here. Correct. So now you realize that torque not only depends on the force, but it also depends on where you apply the force. Where you apply the force. So if you have some body, and let's say this is the axis about which you want to calculate the torque. This is the axis about which you want to calculate the torque, and this is the distance. This is the distance r at which you are applying certain force. Let's say F. Certain force. It could be, one second. It could be like this. Certain force F. Then this force can be split into two components. This force can be split into two components. One force, right, whatever this force is there, this force can be split into two components. One force is the one which is perpendicular to R. One force which is perpendicular to R, and the other force in the direction of the R. In the direction of the R. So this is parallel to R. This is parallel to R. This is perpendicular to R. This is perpendicular to R. Out of these two forces, which one do you think is responsible for causing the torque? Which one do you think is responsible for causing the torque? Think carefully. When you pull it like that, it will rotate. Is F perpendicular responsible or F parallel responsible? F perpendicular responsible or F parallel responsible? Think about it. It's the F parallel which is perpendicular which is responsible. F parallel is not responsible, because F parallel will pull that out. It will pull that body out of the axis, but perpendicular will rotate it nicely. It will give this torque. It will give this torque to it. Correct. So therefore you will see the torque which is there, tau, will be having a value of R. It depends on where you apply it, and also F perpendicular, But this F perpendicular can be written down in terms of F, because if you notice, this angle will be theta, not this. This is R vector, this is F vector. This is R vector, this is F vector. Between them the angle is theta, between R and F. So F perpendicular, won't it be F sine theta? Because F parallel is cos theta. Won't this be F sine theta into basically your R is nothing but your torque, So this is the magnitude of the torque. This is the magnitude of the torque. When do you think torque is maximum? From this, when do you think torque is maximum? If theta is how much? Theta should be how much? How much should be the angle made by the force? If theta is 90, sine 90 is 1. Sine 90 is 1. So when it is 90 degree. And when do you think torque is minimum? If theta is either 0 degree or even 180 degree. 0 or 180. Sine 0, 0. Sine 180, 0. Sine 180 also is going to be 0. How to visualize it? Imagine this force is like that. no torque. Imagine that same force is like that, no torque, because that force will pass through the axis. So either the force is passing away from the axis or coming towards the axis. In both the cases, then the torque will be 0. Correct? But there is also a vector way of writing this. There is also a vector way of writing it, and the torque will be nothing but R cross F. Torque is R cross of F. This is the vector product formula. This is nothing but your vector product. Vector or basically your cross product formula. Vector or cross product. You do not put a dot here. Dot is a scalar product. This is vector product formula. Correct. Very good. How many of you can quickly tell me the unit of torque? How many of you can quickly tell me the unit of torque? Let's see. Yeah, thank you, Pandu. Thank you so much. I just realized that my throat was running dry and I go in the mood. So I use these copper vessels because supposedly they are healthy. Yep, Newton meter. Can I write it as joule? Can I write it as joule? Come on. Can I write it as joule? Yes or no? No. We cannot write it as joule. We cannot write it as joule. No, we cannot write it as joule. Okay? Joule is only for energy or work. Energy or work. Don't use it over here. Yeah. So never ever write it as joule. Although the dimensions are same. In fact, there is a question in units and dimensions which says, are the units of work and torque the same? Of work and torque the same? Units. Answer is no. They are different. Work has joules, but torque has Newton meter. But are the dimensions same? Yes. Dimensions will be the same. Be it Newton into meter, which is also a joule only. So dimensions will be same. Okay. I hope this is clear. Very, very important. Okay. Awesome. Awesome. Now, how to do this cross product? I will teach you some simple rules. How many of you have forgotten or how many of you remember cross product? Do you want me to revise this cross product? If you want me to, say yes. If you want me to, say yes, forgotten. If you know it, say, sir, I know it already. Do you want me to revise it? Or do you want me to, go ahead? Shall I revise quickly the cross product rules? Or do you already know it? Come on, my dear students. And how many of you have called at least 2-3 friends into the session? If you have not yet called 2-3 friends, quickly text them. Sir has started torque and is explaining maybe cross product. Okay. You want me to revise it? Okay. Let's do that. Now, whenever you have a vector A and another vector B making certain angle theta, and you do something called as the cross product, then what you are essentially doing is you are trying to find another vector C whose magnitude will be magnitude of any one of the vectors, let's say A, multiplied by magnitude of any of the other vector, and you multiply it with the sine of the angle between them. That's the magnitude of that. And the direction of C is given by the right hand thumb rule. What you should do in this right hand thumb rule? Everybody use your right hand. Everybody start using your right hand. Take the 4 fingers of your right hand, not the thumb, the 4 fingers of your right hand, and point it in the first vector's direction. Point it in the first vector's direction, which is, let's say, A. So point all the 4 fingers in the direction of the A. Now slowly bend it towards B. Slowly, what will you do? Bend it towards B. Yes, slowly you are going to bend this like this, bend this like this, bend this like this. In case you do that, you will find that your thumb is pointing like that. You will see that your thumb is pointing in this direction. That thumb points in the direction of your C. That thumb points in the direction of C. C is perpendicular to B also, as well as A also. C is perpendicular to both A and B, both. It's perpendicular. That's the right hand thumb rule. Very, very easy. Understood? Exactly. And then I write this as C bar is nothing but A cross B. A cross B. Now, tell me this answer, my dear students. If I do A cross A, what do you think will I get? If I do A cross A, if I do A cross with itself, A cross with itself, what do you think will I get? Come on, quickly. It will be 0, because sine 0 is a big fat 0. That means I cross I, which is also J cross J, which is also K cross K. All these things are a big fat 0. Keep these things in mind. So all these things will be a big fat 0. Also remember one more thing. If by chance I do B cross A, B cross A, then what will happen, my dear students? I will get some another vector D, but this D will 100% be exactly negative of C vector. It will be negative of C vector, meaning that vector D will be pointing downwards. That vector D will be pointing downwards. In such a case, you will hold your right hand not like this, but like that. Not like this, but like that. So your 4 fingers will be something like this. Oh, sorry, I had a few. My bad. Okay, it will be like this, and you will bend it in this manner, and then you will see your thumb is over here. Your thumb is pointing downwards, right? So that will be the next case. If you do the exact opposite. What does this tell you? This clearly tells you it is not commutative. It is not commutative. Keep this in mind. A cross B is not the same as B cross A. That means it is not commutative. Very good. Awesome. Now, what happens if I do I cross J or J cross K or K cross I, right? What do you think the answers are? Or let's say J cross I and then K cross J and then I cross K. In such cases, I will teach you a very easy rule, very easy trick. Within seconds you will get the answer. Within seconds you will get the answer. What you should do is, first of all write I, then write J and K clockwise. I, J, K in the form of a clock. In the form of a clock. Everybody? I, J, K. Write it in the form of a clock. I, J, K. Don't write I, J, K like this. Anti-clock you don't write. Now, remember this. Because you wrote clock like this, clockwise is positive. Anti-clockwise is negative. Anti-clockwise is negative. Just keep that in mind. Now what you do is observe carefully. If there is I, there is J, I cross j will be the third variable. There will be k cap. If it is jk, which is missing? I cap. If there is ki, what is missing? J. Ji, what is missing? K. Kj, what is missing? I. Ik, what is missing? J. This is the first step. It's not yet complete. I'm just showing you the first step. Whichever is missing, you put that first. Clear? Everybody fine till this point? Or else in the exam, you will be like, I cross j or like this, j cross k like this, or I cross k like this, and Narayana, Narayana. You will keep doing this only. Some people are multitasking. They do I cross j here also, j cross k here also. I'm like, what the hell are you doing? This is left hand. You can't use left hand. Left hand rule is not valid. You have to use right hand. Oh sir, silly mistake sir. I was so tense. I thought I will multitask. And I was doing all these things. Please don't do that. Okay? Very good. Now comes the sign. Read it. IJK. IJK. Is it clockwise? IJK. Yes. So it will be positive. Positive. JKI. JKI. Is it clockwise? Yes. It is positive. KIJ. Read it. KIJ. 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 Clockwise. Positive. Is that clear how the sign came? Very good. Awesome. Awesome. Yeah. Very good. Similarly, here JIK. 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 Anti-clockwise negative. KJI. KJI. Anti-clockwise negative. IKJ. 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 Anti-clockwise negative. That's how you do it. Very easy peasy lemon squeezy. Harin Mani asking, sir, what does that thumb actually represent? Don't worry. Okay, till now is this point clear? Then I'll explain you the next point. Till now is this trick very, very clear how to get this using this circular dial, clock dial. If you're loving this, please smash the like button. Please smash that like button. I need your support. I need this channel to grow. You need this channel to grow. If this channel doesn't work for you, then what will you do for your NEET preparation? Because it's not just about English versus Hindi or anything. It's about getting quality content. It's about getting the content from the best teachers. A lot of students across the country watching this channel. And I want your support. I want your help. I want your love in the form of comments, in the form of subscribes, in the form of likes, in the form of talking about this channel to your friends. Very good. Okay, so this is also done. This is also done. Now, what does that thumb exactly represent? So say for example, you know, R is here, F is here, and then when you curl your fingers, etc., I tell you the torque is in this direction. Like, sir, it was rotating like this, sir. It was rotating like this. You said torque is here. What does it mean? Torque is here. I was rotating like this. I was rotating like this. How come torque is here, sir? Think about it. Use your right hand rule. Curl your fingers like this. Where is your thumb going? Where is your thumb going? It's going up. If I say torque is like this, you will be confused. How come torque is there? I am rotating like this. Understand? When I say that torque is here, actually nothing is going here. Don't think, so torque is here. What is going? Is there some force? No, nothing is there. You are applying it like that only. So what it tells me is that if you hold your thumb in this direction, if you hold your thumb in this direction, this is your thumb, then there is no other way, Try to hold your thumb in this direction. There is no other way for your fingers to curl. The fingers will curl in this direction. There is no other way. There cannot be any confusion. It is just a way to represent how it is rotating. If I tell you it is in 3K cap, 3K cap is here, I will hold my thumb in this direction, my fingers will automatically curl here. There is no confusion. If I tell you the torque is in minus I cap direction, I will hold my thumb in this direction, my fingers will curl here. I know it is rotating like this. Why use that? Why not say clock and anti-clock? If I say clock and anti-clock, it could be other way round for other observer. Like, say for example, if I rotate my hand like this, how is it going? How is it going? It's going anti-clockwise, right? Now, see how is it going for you? It must be going clockwise, right? But you know, for me, it is still going anti-clockwise. For you guys, it is clockwise. For me, it is anti-clockwise. So that's the point. Clockwise, anti-clockwise is not the right way. It's not complete. It can create confusion. But this thumb rule will never create confusion. So it is just representing where you should hold the thumb so that the fingers curl and give you the correct direction. That's all. Is that doubt clear? Is that doubt clear, everyone? Very good. Lastly, if you want to find the torque in any general case and it has some I cap, some J cap, some K cap. Let's say for example, they tell you R is I cap minus 2J cap plus 3K cap and the force is 2I cap plus J cap minus K cap. This is what they have told you. And then they ask you what is the torque. Question is what is the torque. What will you do in such situations is use the determinant method. Don't sit and expand this. It is going to be very lengthy. Instead, what you do is look at this technique. I'll remind you of that technique. Write I first, then J next, and then K next. I, J, K. Which vector first? R. Then F. R cross F. That is what torque is, right? I just told you over here. What is torque? Torque is R cross F, not F cross R. That will be completely opposite of torque. Okay. So what do you do next? What do you do next? Start putting the numbers before I, J and K. What is the number before I? It is 1. What is the number before J? Minus 2. What is the number before K? 3. Then go to F. What is the number before I? 2. What is the number before J? 1. What is the number before K? Minus 1. Then you put a big line. Then again write I cap. Put brackets over here. Then put minus brackets and then J cap over here. And then put plus brackets and then K cap over here. Always start with plus brackets I cap, then minus brackets J cap and plus brackets K cap. Always keep this in mind. Everyone? Everybody with me understanding till this point? Understanding this is the determinant method of solving the problem, specifically when it is a huge problem like this. Don't sit and do it for all the things. This I into J, J into K, very lengthy. Don't do that. Directly use this trick which I am telling you, determinant method. What is the next thing that you will do? If you want to find I caps bracket, forget this column, forget this row. Forget this column, forget this row. These four numbers are remaining. These four numbers are remaining. What are the numbers? Minus 2, 3, 1, minus 1. How teacher gave you wrong in the examination? How teacher gave you wrong in the examination? Like this, no? Like this. How teacher gave you wrong in the examination? Check this out. Like this she gave you wrong, correct? This is how teacher gave you wrong. This is how the teacher gave you wrong, right? So exactly follow that path or that pattern. Minus 2 into minus 1. Minus 2 into minus 1. How much is it? 2. 3 into 1. How much is it? 3. Write that down and then subtract the 2. And then subtract the 2. Minus 2 into minus 1, 3 into 1. Is that clear? Very easy way to remember. Similarly, my dear warriors, when you want to find J caps bracket, forget this column, forget this row. What are the numbers? 1, 3, 2, minus 1. 1, 3, 2, minus 1. How are you going to go? How teachers used to give you wrong in the examination. Exactly like that. Exactly like that. Just go exactly like that. So you are going to go basically like this. So 1 into minus 1. 1 into minus 1. Minus 1. 3 into 2. 6. Subtract. That's all. And for the last one, for K cap, forget this column, forget this row. 1 minus 2, 2, 1. 1 minus 2, 2, 1. Just go like this. Just go like this. That's all. Just go like that and you will get the answer. 1 into 1. 1 into 1, 1. minus 2 into 2, minus 4, minus 4, and just subtract the 2. That's it. So I think finally you will get the answer. How much is it? Let's see if you guys have got it correct. Very good. Some of you have got it correct. Minus I cap. Very good. Minus minus plus. So it will be plus 7 j cap, and 1 minus minus becomes plus. So plus 5 k cap. Minus 1 plus 7 plus 5. Very good. Very good. Very good. That's how you solve the question. Now have you revised the cross product? Now will you be able to find the torque in any case? Shall we start with some questions? But one small thing before we start the questions, and that is kinematics in rotation. And that is kinematics in rotation. Just like you had kinematics in translation, there is kinematics in rotation, my dear students. So if there was something which had some angular velocity omega I, and maybe over a period of time, it developed a new angular velocity omega f in a time interval of delta t, and that happened because of some angular acceleration, and all of this happened over some angle. All of this happened, right, over some angle. Let's say that angle which you covered was delta theta. The angle which you covered was delta theta. Angular speed changed in some time interval, angle covered, and alpha. Just like you had kinematics equation in translation, you have same equations in rotation. So final velocity, here it will be final angular velocity. Initial velocity, here it will be initial angular velocity, plus instead of acceleration, alpha, into time. You can also put delta t or t, whatever you want. Here let me just remove that delta t. It will unnecessarily create some confusion. Let's just put it as t. Alpha into t. Very, very simple. Similarly, second kinematic equation, S is ut plus half at square. Here S will be angle covered. Angle covered, which is displacement, angular displacement, is initial velocity into time plus half alpha t square. Third equation, final velocity square, is initial velocity square plus 2 alpha into delta theta. All the kinematic equations are valid. All the kinematic equations are valid. But there is only one condition for this. All these are valid only if, let's say, who remembers that condition? Kinematic equations were valid only under one circumstance. Shivani, the class will end at 11 o'clock or 12 o'clock, I don't know, or 10 o'clock maybe. Only if alpha is basically a constant. We'll be having a break after this problem solving and Pulley problem. After that, we'll be having a short break. Okay, don't worry. Yeah, we'll be having a break after some time. So hold on. I know you might be feeling little hungry. Just hold on for 15 minutes or so. Okay. So let's solve some questions coming up on the screen. Ready? I think you had already put the hearts. Let's do this. A rotating wheel changes the angular speed from this to this in 20 seconds. This was asked in KCET exam, very likely in NEET also. What is the angular acceleration assuming it to be uniform? First, I don't like RPM. I'll convert it into radians per second. And remember, I told you at the beginning of the class, you just have to multiply it by 2 pi divided by 60 to convert it into RPM. 60 goes with 1800. How many times? 30 times. 30 into 2 is 60 pi. So 60 pi radian per second. That's this one. And again, just multiply this with 2 pi divided by 60. See how much does it come out to be? 60 goes with 3000. 50 times 50 into 200. So 100 pi radian per second. Just check this out, everyone. Come on. Now you should be able to calculate the answer very easily. This is final, that is initial. Time is also given. You can say time is also given. What is the angular acceleration? Come on. Formula. Omega final is omega initial plus alpha into time. Final velocity 100 pi. Initial velocity 60 pi. Alpha find out. Time 20. So 20 alpha will be 100 minus 60 is 40. So 40 pi. So alpha will be 40 by 20 is 2. So 2 pi radians per second square. So if you give 2014 paper, you would have got Captain Shreyas as the answer, which is 2 pi radians per second square. Got it? Very good, Janice. Very good, it's cute. Fun and edux. Very good, Siva. Very good, Bandh. Very good, Lakshmita. Very good, Pavita. Very good, Gojo. Congratulations on this. How about an in-text question? Example 6.11, depending on which version of NCERT you are using. So this is an in-text question. The angular speed of a wheel is increased from this to this in 16. What is the angular acceleration? Assuming it to be uniform. How many revolutions does the engine make during this time? Okay, let's see. First of all, are you able to convert this RPM into radians per second by multiplying it by 2 pi by 60? Come on. How much is 1200 RPM? Come on, my dear warriors. Do that. And how much radians per second this is? Multiply by 2 pi by 60. Come on. RPM into radians per second. Quickly do the calculation part. Quickly do the calculation part. Come on, my dear warriors. What is it going to be? 60 goes with 1200. How many times? 20 times. 20 into 2, 4, 40. So 40 pi radians per second. Just check this out. 40 pi radians. Very good. Who is that? Selvan, Santhi. Very good. Sorry, Sahiti. Yes. And what about this one? 60 and 3120. Come on, come on, come on. Not very difficult. It will be 52 into 2. So 104 pi radians per second. Just check this out. Very good. Time is also given to me. Question is first angular acceleration. First question is angular acceleration. So use this. Final velocity is given, initial velocity is given, alpha is not known, time is given. Final is 104 pi, initial is 40 pi, alpha don't know, time 16. 40 and 104, if you subtract the two, you will just get it as 64 pi is basically 16 alpha. So alpha will be 64 by 16, which is nothing but 4 pi radians per second square. So this is one of the first answers. This is one of the first answers of the in-text question, everybody. How many of you wrote it? Very good. Krishna, all of you, Kaushik, Shreya, Janice, Malakordi, Lakshmita, awesome. You also found out the omega values, correct? Now, how many revolutions does it make? Revolutions means angle. Revolutions means angle. So how do I find angle? Use S is ut plus half at square. Or v square is equal to u square plus 2s, anything will do. Just try to find delta theta. Delta theta will be initial velocity into time plus half alpha t square. Initial is 40 pi. So 40 pi into t plus time is, sorry, how much? 16. So into 16 plus half into alpha. Alpha is 4 pi into time is basically 16 square. Come on, just check how much is delta theta coming out to be. Just check how much is delta theta coming out to be, everyone. Check it out, how much is the value of delta theta, but the answer will be in radians. The answer will not be in revolutions, it will be in radians. Come on, quick calculations, my dear warriors. Do it and let me know in the chat box. This much part at least you should do. Your Shreyas sir is doing so much for you. How much is it? How much is it? Come on, come on, come on, come on, everyone. Waiting. Do the math. 16 square, 256. 256 divided by 2, 128. Into 4 you do. Or if you want, take that 16 common. And then also you can do the math. How much is it coming out to be? Is it coming out to be something in thousands? If it is coming out in 1000, yes, correct. Come on. 676, no. I don't think so. No, it is not 676. 672. No. Yes, Lakshmita, I think it should be 1152. Yep. 1152 pi radian. 1152 pi. Keep that pi as pi only. Don't do anything with it. Yes, Sanvi. Yes, Shaktika. Very good, Abhinya. Very good, Shatini. Very good, Krishna. Saiti. Very good, Nitya. Very good, Pandu. Very good, Sanvi. Yes, that's the correct answer. But don't leave the answer like that. Question says number of revolution. Do not forget, one revolution is 2 pi radian. One revolution is 2 pi radian. So 1152 radian will be how many revolutions? Each revolution is 2 pi radian. So these many radians is how many revolutions? Take that 1152 pi, divide it by 2 pi. You divide it into 2 pi, 2 pi, 2 pi. How many 2 pi's are there? How many 2 pi's are there in 1152 pi's? That is the number of revolutions. How much is it going to be? How much is it going to be? Yes, this will be, I think this some of you were answering before maybe. Yeah. How much is it coming out to be? 576. 576. Very good. Very good. Very good. That's how you solve the problem. And now I'll show you the interesting thing. Look at this. A very similar question came in NEET 2022. They directly picked it up from in text without changing any value. That is why NCERT is must. Be it in text, be it back exercise. I can prove it to you in many places. They directly pick it up from summary, directly pick it up from solved examples or in-text problems, directly pick it up from illustrations or back exercise, additional exercise. Directly they are going to pick it up. Sometimes they change the values also. Sometimes they take a part of the problem. So this answer we already know is 4 pi. We just solved this problem right over here. 4 pi, right? The other answer, maybe this time they might ask you this. Who knows? They might ask you how many revolutions. Yeah? Cool. Shall we go ahead? And do you like this? That we do NCERT plus PYQs both in this Super 6 series. I don't think anybody is doing this. Very few people are doing this. Only good teachers might be doing this. English channels, no. Doing unnecessary JE questions. Some people are doing JE advanced. Some people are doing very low questions. No, that is of no use. That is not going to help you in NEET. Prepare over here. Find the torque about the origin when a force of 3 J cap Newton acts on the particle whose position vector is 2 K cap meters. NEET 2020 question. NEET 2020 question. How do you do this? Force is given, position vector is given, torque is asked. Torque is R cross F. R is how much? 2K cap. 2K cap cross 3J cap. 3J cap. 2 3s are 6. KJ. Come on. I, J, K. K cross J will be I cap. But since I am going like this, it will be negative. KJI. KJI. So it will be negative. So it will be minus 6I cap. Where is minus 6I cap? Yes. Option A. A for AIMS. How many of you wrote A for AIMS? Run of FF. Very good. Glad Rutuja loving it. Gojo also loving it like fire. Very nice. Moving on to the next question coming up on your screen, and here it is. Moment of the force about this point is given by. Moment of the force about this point is given by. Come on. Last few questions before the break, and then we'll again meet soon. Come on, everybody. Think about this. Moment of the force at this point. This is the point of application. This is about the point. So when such questions come, first of all, find R by subtracting this point with this point. Subtracting this point with this point. About this point, and the force is acting at that point. So you subtract at with about. At with about. 2 minus 2. How much is it? 0 I cap. 0 minus minus 2. It is plus 2 J cap. Minus 3 minus minus 2. Minus of minus 2 plus 2. Minus 3 plus 2 is minus 1. So minus K cap. So basically your R bar will be 2j cap minus k cap. 2j cap minus k cap. Very good. Now what you do is nothing but use our determinant technique. I, J, K. First is R, which is 0, 2, minus 1. Then is the force, which is 4, 5, minus 6. Then remember, what did I tell you? Brackets I cap minus brackets j cap plus brackets k cap. Come on, fill up the numbers, whatever is going to come up over here. Fill up the numbers, whatever is going to come up over here. See, what are you getting? For I cap, 2 into minus 6 minus 5. 2 6 are 12 minus 5. Come on, minus 12 plus 5. Just check this out. Are you getting this as minus 7? Are you getting this as minus 7? Very good. If you are getting it as minus 7, there are only two options remaining, A or D. Just try for J also. 0 into minus 6, 0. Minus into 4. So plus 4. Yes, so plus 4 will be over here. So minus 4 is coming. So 100% it will be option D only. 100% it will be D. Yes, that's the correct one. And what will be the last one? I think it should be minus 8. It should be minus 8. Perfect. Perfect. Great. That's the answer. Next question coming up on your screen. This is your back exercise. This is your back exercise NCERT. This can also come in your NEET examination. We are solving it right over here. Torques of equal magnitudes are applied on hollow and solid sphere. Same mass, same radius. Both are having same mass, same radius. One is hollow cylinder, one is solid sphere. And torques of equal magnitudes are also applied on them. Okay. Question is, they are free to rotate, standard axis of symmetry, everything, which will acquire greater angular speed. Which will acquire greater angular speed. That's the question. Okay. So tell me, for hollow cylinder, what's the formula? Isn't it mr square? For solid sphere, isn't it 2 by 5 mr square? Masses are same, radius is same. So mr square will 100% be more than 2 by 5 mr square. And we all know torque is I into alpha. So if somebody has more I, that will have less alpha, yes or no? That will have less alpha, yes or no? So alpha for hollow cylinder is less than alpha for solid sphere. So if acceleration is less, omega of hollow cylinder will be less than omega of solid sphere. That's how you prove it. So who will have greater angular speed? The answer for that question will be solid sphere. Will be solid sphere because it has less inertia. That is the answer. Yes, very good, my dear students. Very good. Moving on to the next question which came in J&K CET. This was there in so many places and it got repeated. There is a good chance it will get repeated again here. Constant torque is given, is acting and acceleration is 4 pi radian per second square. The moment of inertia is torque is I alpha. Torque is 3.14 means pi. I is how much? 4 pi. That into alpha. So alpha will be 1 by 4, which is 0.25. 0.25 is A for AIMS. 0.25 is A for AIMS. Very good. Very good. Imagine such a question has come in your entrance test. And this is quite possible. Many people think rotation is difficult because some people don't know till which level you should learn rotation. Yes, you can learn it till mains level. You can learn it till advanced level. You can learn it till Olympiad level also. It is endless. Just like you can learn any other subject. But you should know for NEET what level of questions come. And many people do not know till what level to stop. And that's why they find it difficult. And also you should know how to teach and learn also, that also matters. A solid cylinder of mass 2 kg, radius 4, rotating 3 rpm. If you need to stop it in 2 pi revolutions, how much torque you need? How much torque you need? Torque is asked. Mass, radius, rpm is given. Okay. First of all, I think we need to find alpha. I think only then we can find out the torque. Okay. To find alpha, how much is 3 rpm? You multiply this by 2 pi 2 pi divided by 60, my bad. Yeah. So how much will be this? 3 and 60 goes 20 times. Yep. So this will be 2 to cancel. So it will be pi by 10 radian per second. Pi by 10 radian per second. Everybody with me? Pi by 10 radian per second. Very good. Now 2 pi revolutions is also given, that is delta theta, and it stops. That means final omega is 0. So which equation? Third equation. Omega final square is omega initial square plus 2 alpha delta theta. Final velocity stops, so 0. Initial pi by 10, but square it, plus 2 into alpha. Actually it is retarding, so minus. So I will basically use minus because it is retardation. It is retardation. Alpha into delta theta. What is delta theta? Delta theta is 2 pi. Delta theta is basically 2 pi. 2 pi. Oh, but 2 pi is the revolution. So actually it will be 2 pi into 2 pi, which is 4 pi square. Common mistake. Common mistake. So it is revolution, not radian. So it will be 4 pi square. Did you understand this mistake? 2 pi revolutions. Each revolution is 2 pi radian. So hence it is into 2 pi. Common mistake. Take this over here. Take this over here. 4 2s are 8. So 8 pi square into alpha will be pi square by 100. Pi square gone. So alpha will be 1 by 800 radian per second square. But what will I do with alpha? I want to find the torque. Check this out. I want to find the torque. So torque required is asked. And torque is I alpha, but it is given solid cylinder. So solid cylinder means moment of inertia formula is mr square by 2 and that into alpha. So mass is 2. R is 4 centimeter. So 4 by 100 whole square by 2, this 2. Alpha over there 1 by 800. Come on, do the math. 2 cancels. 4 square is 16. So 16 by 800 into 100. So this goes, 100 square. So 100 square. Yeah. So this will be 2. So this will be 2 into 10 to the power minus 6 Newton meter. 2 into 10 to the power minus 6 is doctor. Just check this out. This kind of question has come in 2019. Yeah. That's the answer. Got it? No, rolling motion is not there. Rolling motion is not there. Yeah, it has been deleted from the syllabus. Okay. Even if it might be there in your old NCERT or all those things, it is not there for NEET. So don't waste your time on rolling, slipping kind of questions. Very good. So shall we start pulleys after the break? Shall we start pulleys after the break? Yep. So let's start pulleys after the break. Let me just put the break slide. Okay, I planned for a break little bit later on, but that's okay. So I think we will meet at what's the time now? 8:43. So 9. Oh my God. Nine 10 p.m. Meanwhile, like and subscribe in case you have forgotten to do that. Like and subscribe. So we'll be meeting at 9:10 p.m. 9:10 p.m. I hope you can see this. 9:10 p.m. around that time. Okay? Chalo. I'll see you in some time. Cool? Don't go anywhere after the break. Hello, hello, hello. My dear warriors, I hope you can see me now and hear me now. Okay, good to see all of you back. Good to see all of you back. I think I had turned off the mic. Yes. Nice to know that you are all back with your dinner completed. And if it's not completed, please get your plate. Please get your whatever food or snacks you are having in front of the computer, in front of the mobile, and watch the lecture. Okay? Finish it quickly. I know you will be running into the kitchen and asking your parents, please serve food, because Shreyas sir has given only a 25-minute break or something. And hopefully your parents give you that food and now you are back. Very good. Nice to see all of you back. Call your friends back to the session. It's time to begin. Time to begin. Smash the like button in case you are new to the channel, in case you are new to the video. Show your love, show your support right now. We need it. We need that full josh. Have you gathered that energy? How many joules of energy have you gathered right now? Did you gather some amount of joules? For the next part of the session, it's going to be a long marathon, like I said. But Shreyas sir needs only one break, even for long marathons, somehow. Why? What is the secret of Shreyas sir's energy? The secret of Shreyas sir's energy is nothing but your love, your like, your comments, your chats, your support. That's all. That's all Shreyas sir needs. Okay? Thank you so much. Keep that chat box live. Get all your friends right now into the session. Thank you, Pandu, for trending WP in the chat box as well. Yo. Chalo, let's begin with pulleys and all that. Now, before we go to pulleys, let me remind you that if, for example, this is R and this is F, right? And this is theta, then the value of torque that will come, in terms of F, theta and R is R, F, sine theta. But you can do one small thing, small trick, and that is you can avoid that sine theta and all of that. You just show your R, and only worry about something called as F perpendicular. F perpendicular is itself F sine theta. F perpendicular is the perpendicular component of the force, and then you can write the torque as R into F perpendicular. It's the same thing, F sine theta. F perpendicular is F sine theta. Correct? You can see that. This is F perpendicular. There is one more way of writing the torque. So, if this is your R, this is your F. Instead of splitting F, what you do, you extend F. This is also called as the line of the force. And what you do is draw a perpendicular. This perpendicular is called R perpendicular. This perpendicular is called as R perpendicular. It's like writing R sine theta into F. R sine theta is R perpendicular. So the torque which will come will be R perpendicular into F. So torque is RF sine theta, or R into F sine theta, which is RF perpendicular, or R sine theta into F, which is R perpendicular into F. All three things are okay. All the three things are okay. Everybody with me on this? Understood? Clearo? Very good. Very good. Awesome. Awesome. Keep this in mind. Keep this in mind. There are three different ways of finding the torque. Now, for pulley problems, one small thing which you should know, I will teach you that. And then solving pulley problems is as simple as solving your normal Newton's law problems, which you have to find acceleration or find what is the velocity after some time and all of that. Okay? So let me explain that to you. Now, when you have a normal pulley which is massless, this pulley is basically massless or basically light. This is light pulley. If this is a light pulley, then what happens is this string has some tension T, this string has some tension T, and this reaction has a tension 2T. Now how does that 2T come? We know because this pulley is not going up, down, or the mass is anyways not there. This pulley is not moving anywhere. So if I write NLM equation, Newton's law equation, it will look something like this. This force minus this force is mass into acceleration. Acceleration, whether there, not there, doesn't matter. But you can see LHS is 0, RHS is 0. So it is a valid equation. So it is definitely a valid equation. But this will not work if the pulley is not light. This will not work when the pulley is not light. When the pulley has some mass, you will have to do a small change. Observe this. Observe this. Observe this. Okay. These are the strings. This is a pulley with mass. This is a pulley with mass. Now, what happens is, there is a small difference. Here, the tensions were equal on both sides, but when pulleys have mass, you will see that it might be having some angular acceleration, and that angular acceleration plays a role in this pulley, because if the tensions were equal from here and here, the pull from this side and this side were equal, then what will happen? Both the torques will cancel. The torque by this tension and the torque by this tension, both the tensions, torques will cancel out each other. There is no reason for the rotation of the pulley. There is no reason for the pulley's angular acceleration. So that's why there are two different tensions, T1 and T2. There are two different tensions, T1 and T2. Keep this in mind. Very, very important. And apart from that, you might have over here the pulley's own weight, which will be, let's say, mg, and this will be completely different tension, which will be T. So this is not T1 plus T2 or just 2T. There are two different tensions. There is weight and that tension is there separately. That's the big change in the free body diagram. Two different tensions. Also, you will notice over here, you will notice if you use net torque on the pulley, is moment of inertia of the pulley into alpha, then this I will be there, this alpha will be there. What do you think will be responsible for the torque? Will mg cause any torque on the pulley? Just answer yes or no in the chat box. Will mg cause any torque on the pulley, my dear students? Think about it. mg is passing through the axis, through the pivot. So when a force passes through the axis, it's like pressing a door on the hinge. There will be no rotation, no cause of motion. So that R will be 0. So 0 into F will be 0. There is no torque only. So there is no torque because of mg. So the torque because of mg is 0. Even the torque because of this tension is 0. The torque because of the tension is also 0 because it is also passing through this point. But will T2 and T1 create torques? Will T1 and T2 create torque? Yes, definitely. If you notice, T2 is acting at some distance. You can see that right over here. This distance is nothing but R, and that is also perpendicular. Even T1 is acting at certain distance, and that is also going to be R. Now, who will be positive, who will be negative? Will T1 be positive torque or T2 will be creating positive torque? Or both are positive or both are negative? So for that, notice how the pulley is rotating. How is the pulley rotating? Clockwise. So now think, which of these two forces creates that clockwise torque or creates an anti-clockwise torque? Look at T2. T2 is acting here. If T2 acts like this down, then it will rotate the pulley clockwise. So it is helping in alpha. So that's why the torque of T2 will be positive, right? So I'll put plus, torque will be R cross F. So R into T2, R into basically T2. Is that clear, everyone? Next important thing, the torque of T1, if you see that T1 will try to oppose the rotation. Alpha is clockwise, T1 is trying to oppose alpha, it is opposite. So it will be minus R into T1, minus R into T1. Is that very, very clear? Is that very, very clear? So this is how your equation of Pulley might look like in some problems. Let's take up a question actually to solve that. Let's take up a question. Imagine that there is a pulley and that pulley is in the form of a disc of certain mass m and a radius r, or I can take the mass as 2m and the radius r. There is a mass here m and there is another mass over here and that is basically 3m, and you leave the system. What will happen? Because this is heavy, this is light, the heavy will go down, the light will go up. And when that happens, the pulley begins to rotate. The pulley will begin to rotate. Very good. So 100% this 3m will have some acceleration downwards like this. This m mass will have some acceleration upwards like this. And because of the accelerations, the pulley will have an angular acceleration like this. The pulley will have an angular acceleration like this. Everybody fine till this point? Very good. Now, what will be the equations of motion? Let's first of all start with free body diagrams. mg will be on m, 3mg will be on 3m. Here there will be tension T1, here there will be tension T2, because I know on the pulley only there are different tensions T1 and T2. There is another tension over here and there is mg also over here. Sorry, that is not mg, that is 2mg because the mass is 2m. So 2mg over here. This is the complete free body diagram of the pulley mass system. If you take mass m, then we'll write for 3m and all of that. This is m. Then we will also write for 3m, and then we will also write for 2m mass, which is actually a pulley. Okay. So for m mass, what will be the equation? Accelerating upwards. So T1 will be positive, mg will be negative. Whichever direction it accelerates, always that is positive. So hence, net force will be T1 minus mg. Big force minus small force is the net force. This is the total force is equal to mass into acceleration. For 3m, it is going down. So bigger force is 3mg. Smaller force is T2. So big minus small, that means 3mg minus T2 will be mass, which is 3m, into acceleration. Force is mass into acceleration. That's all I did. Then when we go to the pulley, don't write F is ma. Instead, what will we write? Torque is I alpha. What will we write? Torque is I alpha. Exactly what we did over here. Net torque is I into alpha. So let's write that. Torque, is it there by tension? No, it is passing through the center. Is 2mg creating a torque? No, that is also passing through the center. So can I write 0 plus 0 first, because no torques by these two? T2 is in the direction of alpha. Wow, so it will create positive torque. So it will be plus R T2. T1 is opposing alpha. T1 will create anti-clockwise torque. So minus R T1 is equal to moment of inertia of the disk, mass R square by 2. So it will be 2m into R square by 2. 2m into R square by 2. Correct? But there is one more thing which I need, and I don't want alpha over there. So is there something else that I can do? The answer is yes. The answer is yes. Observe this carefully. Whenever you have a pulley, all the points on the tangent have tangential acceleration. They have tangential acceleration, correct? And that same acceleration goes to the rope goes to the rope. So even that rope is going with an acceleration equal to the tangential acceleration, is going up or down with an acceleration equal to the tangential acceleration. And what is tangential acceleration? Alpha into r. So can I say alpha is a by r, my dear warriors? Can I say alpha is basically this alpha which is there is nothing but a by r? Wow. So I think we just found out a substitute. I'll just put over here a by r. Alpha is basically a by r. Did you understand this equation? And if you did, put up a thumbs up. I'll just wait for you and then we'll go ahead. I'll just wait for you and then we'll go ahead. Exactly. Just going back to this slide, all the points on the circumference have tangential acceleration, tangential acceleration, tangential acceleration, which is also the acceleration of the rope here and there, all here and there. So AT is A, but AT is alpha r, we saw that, so alpha is a by r. So I will use that over here. So now you will notice this r and this r got cancelled, even this r and this r got cancelled. So T2, so what is remaining? T2 minus T1, 2 also get cancelled, is equal to MA. T2 minus T1 is equal to MA. So what's the next step? Add all of them. Add all of them. If you add all of them, see what and all will happen. See what and all will happen. T1 and minus T1 cancel. T2 and minus T2 cancel. 3mg will be there. 3mg will be there. And minus mg will be there. Correct? 3mg from here, minus mg from here, T2, T2, T1, T1 cancelled. When I add all these three upper equations over here. Now what is the next step? Here, MA, 3MA, MA. MA, 3MA, MA. Very good. So 3mg minus mg, 2mg. MA plus 3MA plus MA, 5MA. MM cancel. A will become 2g by 5. Very good. That's how you find the acceleration. Amazing, right? How we solve Pulley problems. Okay? This kind of question is very likely that it might come if you get Pulley with mass questions. You won't get very difficult, complex questions, something and all is happening, Pulley is moving, constrained motion is there. Those kind of questions do not come even in JEE mains. So why would you solve it for NEET? So please do not do those kind of complex questions where pulleys are moving with acceleration in constrained motion and all of that. Not there. That too with mass. No. I think we should solve a question. This is there as a example in your NCERT. This is an NCERT 6.13 question. Are you ready for it? A rope of certain negligible mass is wound on a hollow cylinder of mass 3 kg. Radius 40 centimeter. What is the angular acceleration of the cylinder if the rope is pulled with a force of 30? What is the linear acceleration? Assume that there is no slipping. Okay, let's try to do that. Okay, I hope this is clear. Bikram, can you do one thing? Can you watch the replay? I think it is a very straightforward question. Whatever I just did, I have explained every step in detail. If you want, you can pause the video, you can watch it at 0.5x speed also. Okay? All I have done is, I have told you when pulleys are light, then TT are same. But when pulleys have mass, then tensions are different. The difference in the tensions is what creates the torque and creates the angular acceleration. So in this problem, where one mass is more, one mass is light, the bigger mass will go down, lighter mass will go up, accelerating rotation wise the pulley. So for this mass, I write F is ma. For this mass, I will again write net force is mass into acceleration. For this pulley, just like I wrote here, net torque is I alpha. The same equation I wrote here, net torque is I alpha. Many things got cancelled. So 2 also got cancelled. I just got ma. I took this equation and this equation. I added them. Again, few things got cancelled. Solving algebraically, you get A as 2g by 5. Is that okay? Cool, what we just did? Alright, let's do this question. So, understand the diagram first. This is wound on a hollow cylinder. So, imagine I am looking at the side view. This is basically your hollow cylinder. Right? So this is your hollow cylinder, and basically you are applying a force of 30 Newton. You are basically applying a force of how much? 30 Newton. Okay. The mass of the hollow cylinder is 3 kg, and the radius is 0.4 of a meter. The radius is 0.4 of a meter. It is acting perpendicular. Okay. So because of all these things, what will happen? 100% there will be a torque, there will be an angular acceleration also. And the question is, what is the angular acceleration and what is the linear acceleration? Okay, first of all, if you look at this, is there a torque on this? Is there a torque on this cylinder because of the 30 Newton? Yes. So what will that torque create? It will cause angular acceleration. How much is the torque? R into F. R into F. What is the moment of inertia of a hollow cylinder? Mr square by 2, and this into alpha. One of the r's just got cancelled. So won't alpha be 2F by Mr? 2F by Mr. So what is the force? 30. What is the mass? 3. What is R? 0.4. Come on, my dear students, what is the value of alpha? Quickly calculate and tell me. Calculate the value of alpha and tell me, my dear students. Come on. Tell me the answer. Waiting for all your chats. Waiting for all your chats. Come on. Do the math. 33 goes 10 times. What is the value of alpha that you are getting? Oh, sorry, it's a hollow cylinder. My bad, guys. Mr square by 2 will not be there. So sorry. I made a mistake over here. So sorry. It's a hollow cylinder. So it is just Mr square. So alpha will be just F by Mr. My bad. Force is 30. M is 3. R is 0.4. R is 0.4. Is that right? Okay. So 10 by 0.4. Yeah. 10 by 0.4. 10 by 0.4. It was a hollow cylinder. Yeah. So 10 by 0.4. 0.4 is how much? 4 by 10. 4 by 10. This will go 5 and this will go 5. So is it 25? Is it 25 radians per second square? Is it 25 radians per second square? Everyone with me? Very good. Very good. No, it's not 50. By mistake, I had put that 2. That 2 will not be there. It will be 25. That's the first part. What about the second part? What is the linear acceleration? Linear acceleration is angular acceleration into radius. Linear acceleration. A, what was it? A is alpha into R. I had told you. Alpha is 25. What is the radius? It is 0.4. 25 into 400 into the decimal will make it 10 meters per second square. That is the linear acceleration. Cool? These kind of questions are there in your NCERT, can also come for your NEET examination. Okay, so I've shown you some problems on pulleys also. They are rare, but if it comes, now you know how to do it. Okay, we had our break. Shall we now move to equilibrium? Because after that we'll go to energy and then angular momentum. So talking about equilibrium, look at this. Have you ever stood like that? Have you ever stood like this on one leg? On one leg. Have you ever stood on one leg? How many of you have stood on one leg? This Pandu is right now standing only on one leg. And have you tried balancing yourself on one leg? So, when you are balancing yourself on one leg, right? And you are stationary, you are said to be in equilibrium. You are said to be in equilibrium. Equilibrium means that there is no translation. There is no translation. Also, there is no rotation. Also, there is no rotation. Equilibrium, stationary. Punishment by teachers. Oh my God. Great. So, in such situations, what is the condition on that body? The condition on the body is that if you count the total force and add it vectorially, the answer will be a big fat 0. The total forces, maybe there is mg, normal, friction, this, that, everything, all forces cancel out. Not just that, the net torque on the body is also 0. Obviously, it is not rotating. If there is no rotation, net torque only will be absent because alpha is only not there. But always torque is measured about a point. So about which point? The answer is about any point. About any point. Remember that. About any point, the torque will be a big fat 0. Yes. Yes. Correct. Correct. Very good. So there are certain questions based on this equilibrium concept where net force is 0, net torque is 0 about any point. Doesn't matter which point you take, every point will see that it is not rotating. It is not, having any kind of motion. So let's have a look at, one of the question which is there in your NCERT. So most of these NCERT questions can get repeated in your exams. And you would see that in previous year NEET. There is a metal bar of 70 centimeters, very nice question actually, and 4 kg in mass. This entire bar, look at this, from A to B is how much? 70 centimeters and 4 kg in mass. Supported by 2 knife edges, K1, K2. I hope you can see that. There are 2 places where you are supporting it. It's like holding it here and here. It's like holding it here and here. Not at the end, but somewhere in between. Somewhere in between. I hope you are able to visualize this. Somewhere in between. Okay. Now, this is 10. This is also 10. Now you keep a 6 kg load. You can see P point is the point where you are keeping that 6 kg load at 30 centimeters from one of the ends. Okay. What is the reaction at this and this? Now see, if this 6 kg load was not there, aren't these 2 knife edges symmetrically placed? If that 6 kg load was not there, this and this are symmetrically placed. So only the mass of the rod is there, which is 4 kg. So 4g force down. So this reaction and this reaction, how much do you think they would have been if this 6 kg load was not there? If that 6 kg load was not there? Think about it. This 4g will be balanced by these 2 forces, yes or no? So they will be equal also because it is symmetrical. So this will be 2g, this will be 2g. This will be 2g, this will be 2g. Agree or disagree? But the moment you add 6 kg mass and that to here, another 6 kg mass, slightly left side, who do you think will become larger? This left side force or right side force? If more weight is concentrated slightly towards the right side, don't you think the right side will press the knife little more than the left side? So, or sorry, what is this? This side, left side will press it more than the right side. Yeah, so what will happen? This will increase and this will decrease. Yes, very nice, very nice. So, question is how much is this value and how much is this new value? I hope now you are able to visualize the question. That is the first step. Okay. Now, let us try to, write down all the forces over here. I think most of the forces are already shown, but still I will show them for you. This is one force, which is N1. This is another force, which is basically 6G. This is from the center of mass of the rod. How much is it? 4G, that is 4 kg. And this is another normal from the another knife edge, which is N2. Now, if I use net force is equal to 0, N1, N2 or upwards, 4G, 6G downwards, 4G, 6G downwards, that is 0. So what will N1 plus N2 be equal to? Won't it be 10G, which is basically 100 Newton? So N1 plus N2, is it coming out to be 100 Newton? Everybody with me understanding till this point? But N1 and N2 are not equal. N1 and N2 are not equal. Okay. How do I find that? I need one more equation. So if you go back over here, I told you net force is 0 is one equation, net torque is 0 is another equation. So let's use that. But choose a point which is convenient to calculate. Don't choose a complex point where it is difficult to calculate. So if you notice over here, if I start marking certain distances, observe carefully. Observe carefully. This total length was 70 centimeter. Total from B to A. It is clearly mentioned that this much is basically 10. Now this is 70. The center will be at 35. The center will be at 35. So 35 is from here till here exactly. Okay. If this is 10 and it is also mentioned that 6 kg is at 30 centimeters from one end. So 30 centimeters. So this is basically 30. That's what it says. If this is 30, this is 10. How much will this be? How much will this be? Come on. I want to see the spam in the chat box. I want to see the spam in the chat box right now. Let's see if you are able to geometrically calculate it. Meanwhile, let me just drink the water. How much is it? 20? Very good. Very good. Very good. That is 20. Excellent. Now, I will choose a beautiful point to calculate the torque, and the point will be this point. I will choose this point. So, I will choose net torque about knife edge 1 is 0. Net torque about knife edge 1 is 0. So tell me, will N1 create a torque about this point? No, it is passing through the point itself. It's passing through the point itself. How can it create torque? No. So that will not even create a torque. Will this create a torque? Yes. N2 will definitely create a torque, but for that I need this distance also. How do I get that distance? Well. This is 10. This is 10. 10. It is clearly mentioned. It is supported by knife edges 10 centimeters from each end. So this is 10, this is 10. So how much is this distance, my dear students? From 70, subtract 10 and subtract 10. Subtract 10 and subtract 10. Won't it be 50? Won't it be 50 from here to here? Won't it be 50 from here to here? Very good. Very good. So now, how much will be the torque of N2? R which is 50 into N2. So it is R which is 50 centimeters into N2. But that is anti-clockwise. What about other torque? 6G. 6G will create clockwise torque. So 100% I will put negative. If I choose this negative, the other one will be positive. Doesn't matter. Whichever direction you want to choose, you can choose as positive. Is that okay? Is that okay? Very good. Very good. Now, what about 4G? What about 4G? Think about it. And 6G. This 6G is at a distance of 20 centimeters. This 6G is at a distance of 20 centimeters. So 20 into 6G. So 20 into 6G. But that is clockwise. This 4G is also going to create clockwise torque. So again a minus sign. So their sum will be 0. Net torque will be 0. Now, how far is 4G from this point? Okay, carefully analyze it. Carefully analyze it. From here to here. Oh my God, I don't want this. Please go back. Please go back. Okay. From here to here is 35. From here to here is 10. So from here to here is how much? So from here to here is how much? This is 35. This is 10. Won't this be 25, my dear warriors? Won't this be 25? How many of you are able to see this as 25? Very good. So that's why that will be 25 into 4g, but that is clockwise, so negative. If you take this minus, take these two as plus. Perfecto. Now you can solve this equation. There is nothing left in this equation. So basically 50 into N2 will be 20 into 6, 120g, 25 into 4, 100, 100g on the other side. So which is 220g is equal to 50 times of N2, 0, 0 cancels. So N2 will be 22 by 5 times of g. G is basically 10. So it goes 2 times. So it will be 44 Newton. So that is the value of N2. Assuming g is 10, if it is 9.8, it will be slightly less. Okay. And you can substitute it here now. You can substitute it here now. So N2 is nothing but 44. So N2 is nothing but 44. So that is basically 100. Therefore, N1 will be 56 Newton. So that is the second answer. Did you understand how to solve this question? Each and every step I have explained it to you. If you got confused here, please draw your own diagram. That is the best thing. Or just watch the replay step by step. Every point to every point distances I have calculated. The tricky part about this problem is not this. It is this, where you have to measure the distance. Most of the people make a mistake in the distances. Very good. Many of you wrote 56 as the answer. Very nice. A very similar question is there in the back exercise also. If you can solve this, very good. There is a stick balanced on the knife edge at the center when 2 coins each of 5 grams, that means totally 10 grams. On the other side at 12 centimeters, the stick balances at 45. What is the mass of the meter stick? Okay, let's do this. Drawing the diagram is essential. Without that, it will create a lot of headache for all of us. So this is our meter stick like this. Okay, this is our meter stick. Cool. Or shall I use this? Wow, nice. This meter stick looks good. Okay, and it is balanced at the center. Okay, obviously. But if you add 5 grams together at 12 centimeter mark, so you add 5 grams and 5 grams at 12 centimeter mark, that means somewhere over here. So totally it will become how much? 10 grams. 10 grams. So it is basically 10 gram weight. So 10g is the force because of those 2 coins at 12 centimeter mark. So 12 centimeters is from here till here. This is 12. What is the length of the stick? It is a meter stick. That means it is totally having a length of how many meters? 1 meter. So this is 100 centimeters. 100 centimeters. Okay. Next, the knife balances at 45 centimeters. So 45 centimeters will be not exactly at 50. It will be slightly here. So this is where it balances itself. This is where it balances itself. And what is given is this distance is 45. This distance is 45. Now please remember, the scale which is there, the meter stick which is there, the center of mass will actually be here, exactly at 50 centimeters. That's where you will have mg. That's where you will have mg. That's where your center of mass of the stick, would be. And that distance obviously is going to be none other than 50 centimeters. Is that much part clear? Very good. So now, if I draw one more force and that one more force will come over here, the support will exert some reaction. So I'll call that as R. Okay. So now everything seems to be okay. And I can write R is equal to 10g plus mg. This is because total force will be 0. Total force will be 0. So R will be equal to 10g plus mg. This much is okay. This much is okay. Very good. Now what do we do, my dear warriors? Observe carefully. What did I tell you in the theory part? After writing this equation, try to write this equation. You might need both, sometimes only one. In the previous problem, we needed both the equations. Now, let's see whether we need both or not. Choose a convenient point. I feel the convenient point is always the hinge, the pivot, everything, because everything can be easily calculated about that pivot. So if you take this point and say the net torque about that pivot is 0, the torque because of R, how much is it? How much torque will be there because of R? We have to calculate the total torque. Every force will contribute. So because of R, how much torque will it contribute? That R is passing through the axis, through the hinge. How much will it be? How much will it be? Come on, think about it. Yes, 2 coins are there, Shiva Prasad. That's why I have made it as 10G. No, 5G plus 5G is how much? 5G plus 5G, 5G plus 5G, how much will it be? 2 into 5G, how much will it be? 10G, right? So I put it over there already. Yes, I have already taken it as 2 coins. Don't have to worry about it. 0, very good. So R will have 0 contribution. So R will have 0 contribution. Very good. Let me put 0. What about mg? I think that will try to rotate the stick clockwise direction. mg will try to rotate it like this. It will try to bring it down like this. So clockwise. If I make it positive, how much will be the torque? Calculated. If this is 50, this is 45, can you quickly guess how much is this value? From here to here is 50, from here to here is 45. So how much is that remaining part? Obviously it will be 5. Obviously it will be 5. So can I say it is R into F, which is basically 5 mg? R into F, which is basically 5 into mg. Till this point it is clear? Very good. What about this 10G? How far is it? Check this out clearly. From here till the end is 45. From this point to this point is 12. 45, 12. How much is this? How much is this going to be? 45 minus 12. How much is it? 33. So there you go. But that will create an anti-clockwise torque. If mg created clockwise, 10G created anti-clockwise. See how it is trying to pull it? It's trying to rotate the stick anti-clockwise. So anti-clockwise, I'll put it as minus. So it will be 33 into basically 10G. This whole thing is 0. GG cancels. So what will I get? 5 times of m is equal to 3 into 10. So 5 goes with 10 2 times. So therefore m will be 66, but it will be in grams. 66 grams. That is the answer. Yes. Very good. Excellent, my dear warriors. If you have understood it till here, I am really super duper proud of all of you. Okay, I have explained each and every step. Like you can see in equilibrium problems, what is the critical crucial part? Marking the lens. From this to this, that to that. If you are okay with that part, I think rest will be easy. And remember, torque. You have to always take a pivot point and then measure the torque. Measure the proper distances. And be careful with the sign. If you choose one direction positive, other direction automatically will become negative. Okay? So, that's what it is. How many of you have seen this example and you would have broken your head on this? You would have broken your head on this. How many of you have broken your head on this diagram, which is there in NCERT? There is a ladder, and this is a very common question, guys. If there is a ladder, this is a support. You would have seen that a ladder is stable only under certain situations. When the angle is less, it's very difficult to hold the ladder. When the angle is more, then it is very easy to hold the ladder. Here, this ladder might just, probably slip. Might just slip. Here, it is firm. Maybe it is in equilibrium. Here, maybe it is just in equilibrium. Who knows? Maybe it is just in equilibrium. So, all possibilities are there, depending on how the angle is. When the angle is like this, then what happens? There is a good chance it will just slip. You can try it out. Take a pen, take a scale. You will have a corner in your room. Try to keep the scale almost like this. It will stay. Try to keep the scale like this. Probably it will stay, maybe. Try to keep it more. It will fall. Try it out right now if you want to. Try it out right now and you will see how beautifully it will fall off. Can you just try it out and give me a thumbs up? Quickly, take a scale, take a stick, take a even 15 centimeter scale will do, and try to put it at the corner and see whether it stands when the angle is more, and when the angle is less, it will doop, fall, dumal. Yeah, just try this out. So exactly this question. So what kind of forces will be there is that you will have your weight, you will have a normal, you will have another normal from here, N2, N1, maybe there is a friction from here, maybe this wants to fall down like this, maybe there is another friction over here. So these are basically the forces which usually act in this case. Gojo tried it, Lakshmikanta Kumar tried it. Wow, so cool, yeah, so cool. Krishna also tried it and experiment was successful, looks like it. Very good, awesome. So you would have realized because it tries to fall behind, so friction will try to pull it behind. Because this end tries to fall down, so friction will prevent it from slipping by acting upwards. Normal from the vertical wall is horizontal. Normal from the horizontal floor is vertical. The weight will act from the center of mass. Here in this diagram, they have already shown all the forces. Friction, you can see, is F here. Normal is already N. F2 is the combination of normal and friction. F2 is the total force by normal and friction. Here this wall is smooth, so there is only one force. So I will mention the word smooth over here so that you don't get confused. Here there is friction. This F stands for nothing but friction. And this is 1 meter. I don't know whether it is seen clearly. This is 1 meter. You can open your NCERT also and see. Now, okay, let's try to do this question. First, let's apply net force is 0. Net force is 0. But you know what is strange in this problem? And that is different from either this problem or even this problem. In this problem or even this problem, the thing was everything was in one dimension. Here it's in 2 dimensions. So I will do it separately for x, separately for y. If you look at x direction, there is friction here. Nothing else is in horizontal except for F1. Only 2 forces. So can I say F minus F1 is 0? Therefore, F will be equal to F1. This is in x direction. This F like this and this F1 like this. These are the only 2 forces in the x direction. So net force in x direction is 0. Sorted. What about y direction? Weight is acting down. Oh, normal is acting up. Only 2 forces. So normal acting upwards is balanced by weight acting downwards. Don't worry about F2. F2 is the resultant of N and F. Don't worry about it. N is equal to W. Perfect. But do I know the value of W? Yes. Weight is 20 kg. So this is 20 G. So basically it is 200 Newton. So that is the value of N. Okay. Cool. I'll leave it as it is. Now let's look at the torque equation. Net torque is 0. After net force is 0, the next equation should be net torque is 0. Which point will you choose? Choose a convenient point. Choose an edge or pivot or hinge. Choose this point over here. It is easy. So choose that point A, which is at the bottom. Will the normal create any torque? No. Will the friction create any torque? No. Why? Because they are passing through the point. They are passing through the axis, so they cannot create any kind of torque. Will this F1 create any torque? Yes. But how much torque will it create? So for that, remember I told you some time back, there are two ways of calculating torque, and I showed it to you right over here. You can split force or you can split R. You extend the force, draw a perpendicular, R perpendicular into F, R perpendicular into F. Yes, extend that line of force. It becomes easy in this problem. Here, that's exactly what I'm going to do. This is the line of the force. If you observe carefully, if you observe carefully, this is the line of the force. If I drop a perpendicular, it will go like this. If I drop a perpendicular, it will go like this. How much is this perpendicular length? It's exactly this length, which is 2 root 2, which is exactly 2 root 2. So hence, the torque by this force F1, which is going to be anti-clockwise. This F1 is anti-clockwise. So maybe I can take it as minus. So 2 root 2 into F1, anti-clockwise torque. That's the first term in the equation. How many of you got this? Is that clear? Very good. The next term, weight is acting like this. If you notice, this is the perpendicular distance. This is where your weight is acting. This is where your weight is acting. If this is 1 meter, this is 0.5 meter, this is R perpendicular, and that is creating clockwise torque. About this point, it will rotate it clockwise. So plus 0.5 into W. This is 0. So solve this now. Solve this now. So take it on the other side. So 0.5 W means half into weight. How much is the weight? mg, which is how much? 20g, is equal to 2 root 2 F1. Now 2 cancels and F1 is asked. So F1 will be 10g by 2 root 2. So 10 by 2 is 5. So 5g by root 2. So F1 is 5g by root 2 and F1 is also F. F1 is also F. Therefore, F equals F1 equals 5g by root 2. So that is one of the answers. This is one of the other answers. F1 I found out, N also I found out. If you want to find F2 by any chance, then what you do is, in order to find F2, realize F2 is actually vector sum of normal and friction. So F2 will be nothing but N square plus F square. N square plus F square is F2 square. So substitute value of N and F over here and you can get it out. That's all you need to do. If angle is asked, let's say with this or horizontal or vertical, let's say for example this angle is asked. If that angle theta is asked, what will you do? You will say, let's say tan theta or cos theta, right? Whatever. You can say, for example, tan theta, tan of theta. You can see in that small little triangle, this will be F, this will be N, this will be F2. That's all. So tan theta will be opposite by adjacent. So it will be F divided by N. So that's how you can find tan theta also if needed. But in NEET, all these things will not come because only standard angles tan and cos and sine will come. Non-standard will not come. Cool? Understood how to solve this question, ladder problem? How many of you had difficulty in this problem or the previous problem? And because of today's lecture, it has got cleared. Let me know. How many of you had tried it before but failed to understand it, but now you understand it in a very simple way? The NCERT solution is also little crazy. I mean, I don't like it. Let's move on. Shall we go to the last two parts, which is rotational energy? Yeah, very good, Janice. You had difficulties in that too. Very good, Gojo. Nice. Let's talk about rotational energy, work and all that things. Okay, tell me, in translation motion, what was kinetic energy? What was kinetic energy? Wasn't it half mass into velocity square? Very good. What was work formula? wasn't it force into displacement? Wasn't it force into displacement? Correct. What was power? Wasn't it force into velocity? Force into velocity? Very nice. Now, similarly, think in rotational motion. In rotational motion, what will be the kinetic energy of rotation? What will be the kinetic energy of rotation? Will mass be there? No. Instead of mass, who will be there? Rotational mass. What is it called? Moment of inertia. So half I omega square will be there. Correct. Very good. Very good. Similarly, work. Work is force into displacement. What is the equivalent of force? That is torque. What is the equivalent of displacement? That is angular displacement. K is half I omega square because omega was equivalent of V, I was equivalent of S. Work is torque into delta theta because torque is like force, delta theta is like displacement. Similarly, what do you think power will be? Instead of force into velocity, it will be torque into angular velocity. So these are the energy related formulas in rotational motion. If you know translation, you can easily understand rotation. If you know translation, you can easily understand rotation. Very good. Awesome. Awesome. So how about some questions? Okay, these kind of questions have come in many NEET exams. Solid sphere of mass m radius r is rotating. Solid cylinder of the same mass, same radius is also rotating, but with double angular speed. Find the ratio of the kinetic energy. Find the ratio of the kinetic energy. Let's see if you guys can do this. First, rotational kinetic energy of the, what is it? Solid sphere. Half into mass into, solid sphere moment of inertia is 2 by 5 mr square. This is moment of inertia. Half I omega square. What is omega? I don't know, but I'll just assume it as omega square. That's the first term. Next, for the solid cylinder, the rotational energy is half. Solid cylinder is like a disc. So moment of inertia is mr square by 2. Angular speed is double. So 2 omega whole square. Now comes the last part where you divide them. Now the moment you divide them, this half, this m, this r square, this m, this r square gets cancelled. Even this omega and this omega will get cancelled. And what are you left out with? This 2 is there, this 5 is there, this 2 goes on the top, this 2 has gone on the top, this has just 1 by 2 square. That's what I believe is left. 2 square cancels. I am left with 1 by 5 now. So that is Ames. Ames is the answer. Yes, option A is the correct answer. Very good. Harini, more 1 hour at least. More 1 hour. I had already told that this session will be very long because it's a major chapter. We have to kill the monster. And who is the monster? Rotation. And I'm going very systematically right from basics so that any student who wants to learn this chapter in detail from the scratch, from the basics, from NCERT for NEET with PYQs, this is the only session you will need. You will not need any other session. Within 5.5 hours, your entire chapter will be done. Correct. Moving on. A solid cylinder rotates about its axis with angular speed 100. Radius of cylinder is 0.25. What is the kinetic energy associated with the rotation? What is the magnitude of the angular momentum about the axis? Okay, now this part we will do it later on. Don't worry about this part. Okay, so just ignore this. Angular momentum will come in the next slide after rotational energy. Just ignore that part. Only solve the kinetic energy part. Look at the question. Solid cylinder mass, speed, radius. Find the kinetic energy. Kinetic energy is half I omega square. Solid cylinder means like a disc. So it is mr square by 2 into omega square. So it will become 1 by 4. 2 2s are 4. mass is 20, r square, radius is 0.25. 0.25 is like 1 by 4. 0.25 is like 1 by 4. So I'll make this as 1 by 4 whole square. Omega is 100. So 100 square. Come on, my dear warriors. Come on, my dear warriors. How much does this kinetic energy come out to be? Calculate this. It's not very difficult. 20 goes with 4 5 times. This will be 100 square. So 10 raised to 4. This is 4 square. So this is 16. Come on, do the math and tell me what is it that you are getting. Tell me what is it that you are getting. Come on, come on, come on. You can make it as 50 by 16 also, so that you can do the division easily. So that you can do the division easily. Come on, come on. Tell me what is the answer. 16 3s are 48. Come on, it will be 3 point something, the 10 to the power 3. I can make it as kilo, so kilojoules. So that is your kinetic energy. What is it coming out to be? Come on, put up the answer in the chat box. Do the math quickly. Come on, 16. 2 is remaining, 21. Then what will come? 2 and then 5. Just check this out. 3.125 or 3125 joules. One and the same thing. How many of you got it? Come on, come on, do the math. 16 divided with 50. 3.125. Yes. Yes. Gravitation also will do, Siva Prasad. Don't worry, it will also come. Definitely. Excellent. Excellent. So that is the answer. This is also NCERT question 6.11. You can see depending on which version of NCERT you are using. So that's the question. Next question. To maintain, this is very straightforward. This is also there in NCERT. To maintain a rotor, that means a motor like thing, at a speed of this much, engine needs this much torque. What is the power required by the engine? What is the power required by the engine? Come on. Come on, find out the power required by the engine. Is there a formula for power? Just like power is force into velocity, it will be torque into angular velocity. What is the torque? Torque is 180. What is omega? It is 200. So how much is it? 36,000, but it is joules per second or watts, or you can also say 36 kilowatt. 36 kW. Exactly. Very good if you wrote 36 kilowatts. Proud of you. Okay. Very straightforward question which is there in NCERT can also come in different ways in your NEET exam. Don't ignore any problem. That's the reason why I'm doing NCERT questions for you. That's the reason why I'm doing PYQ questions for you. That's why I'm doing some unseen related pattern type, predicted type questions for you based out of completely new syllabus. Complete new NCERT, because NTA is going to use that. Your NMC is going to use that. Remember. This example in text question, a cord of negligible mass wound on a flywheel, radius 20, steady pull is applied on the cord, flywheel is mounted on the axle, find the acceleration, find the work done, find the kinetic energy, compare parts B and C. Okay. I will just draw the diagram on the next slide because there is not much of space over there. So this is what it is. There is some radius, right? How much is it? 20 centimeter and mass is 20 kg. This is 0.2 meter. This is 0.2 meter and this is 20 kg of the flywheel. Okay, right? Okay, and the cord is as shown. The flywheel is mounted on the horizontal axle and a steady pull of 25 Newton is applied. Steady force of how much? 25 Newton is applied. So 25 Newton from here. So because of this, what will happen? There will be an angular acceleration definitely, and you will see that this point will move down, and I think they have given also by how much does it move down? By moves down by 2 meters. Moves down by 2 meters. So it has moved down by 2 meters. Okay. So let's try to find out everything. Yep, let's try to find out everything. First, what have they asked? Listen, compute the angular acceleration of the wheel. So let's try to find alpha. So to find alpha, is there any technique? Yeah, I think so. We can use torque is equal to I alpha, right? Torque is equal to I alpha. What is moment of inertia of a flywheel? It's like a disc. So mr square by 2 into alpha. Mr square by 2 into alpha. Everybody fine till this point? Okay, it's like a disc. You can treat this flywheel like a disc. That's why that 1 by 2 factor has come. Okay. Next, alpha I want to find. So torque. Oh, wait a minute. I can also write torque as R into F. R into F. Okay. R cancels. So therefore, alpha will be 2F by mr. Okay. So what is the value of the force? 25. What is the value of the mass? 20. What is the value of R? It is basically 0.2. Come on, my dear warriors. Do the math and tell me quickly what is the value of alpha. Quickly. This 0, this decimal cancels. This 2 cancels. So is it 12.5 radians per second square? This is the first answer. This is the first answer, 12.5. Check it out. Yep, option A, first question is done. Everyone? Clear? How many of you lost energy till now? Sir, what is happening? Oh my God, so much rotation, sir. So much rotation, sir. Very good. Keep up the Josh. I want you to build stamina for 5 hours, 6 hours. Exam is for almost 3.5 hours. But remember, your actual exam starts also 1 hour before, because you're entering the hall, your mind is tensed, you're thinking about so many things. You are getting distracted, you have to fill the form properly, you have to enter the hall properly, everything is there, you have to sit the right place, right? You are so scared. And that's why that mental stress is there for almost 4-5 hours. And if you lose focus after 1 hour, 1.5 hour, the rest of the paper you will do in a hurry, you will make silly mistakes. So that's why you should have that stamina to sit in a fixed position and attend a lecture or solve problems for a stretch 5-6 hours. At least 1 day a week, at least try to do that. 1 day a week. Okay, moving on. Elastic collision, no energy loss. Very good, Siva Prasad. I love your reply. Next question. Find the work done when 2 meters is unwound. Work when 2 meters is unwound. I think I can use this concept that work is force into displacement. Force is 25 Newton. 25, I'm pulling it by 2 meters. So it is basically 50 joules. Work is 50 joules. Perfect. This question also I have done. Third question, find the kinetic energy of the wheel. Assume it starts from the rest. I know alpha. I think I can find kinetic energy by one method. First, I'll find omega. From that, I will find kinetic energy. But to find omega, how do I do that? Because I just know it came down by 2 meters. Okay, I'll tell you what, in this question, there is a small trick. When this wheel is there over here, like this, after some time the wheel rotates. After some time, let's say that point maybe comes over here, and thread wise it comes over here. This has come down by 2 meters. The wheel has rotated by certain angle delta theta. See this. It has rotated by certain angle delta theta. Isn't this part of the wire or the rope or the thread exactly equal to this part, which is the arc? Because that point when it comes down, that much part will get unwound. So the part on the wheel which is exposed is exactly the part of the thread which is opening up and falling down. So can I say the length of the arc which is here is equal to 2 meters and length is r into delta theta, which is 2 meters, and radius 20 centimeter. So 0.2 into delta theta is 2. So delta theta is 10 radian. Delta theta is 10 radian. That is the angular displacement. How many of you realize this? If you realize this, brilliant. If you understood my explanation, also very good. So when that wheel rotates, a part of it gets exposed, and that part which is exposed is the arc, and that part exactly is also the thread which comes down, which is also given to be as 2 meters. Where is it mentioned? 2 meters. See, right over here, 2 meters. So now using this, I feel I can find out the angular velocity. I can find out the angular velocity. Assume it starts from rest. Which equation? Omega final square is omega initial square plus 2 alpha delta theta. Final velocity, I don't know. Initial velocity, 0. Alpha, I found out to be 12.5. Delta theta, 10. So this will be nothing but 250. So omega f square is basically 250. Just check this out. Everyone, omega f square is 250. Now, what is the next step? To find the kinetic energy, use the formula half I omega square. I value is mr square by 2. I value is mr square by 2. Mass is how much? 20 kg. R is how much? 0.2 square by 2. And how much is omega square? How much is omega square? Omega square is 250. Omega square is basically 250. Very good. That's it. So this 2 cancels. 10 divided by 2. This is 2 square, which is 4. And this will be divided by 100. And this is 250. 1 0 1 0 goes. This goes with this 2 times. Even this 0 and this 0 goes. Check this out if you still get this as 50 joules. Check this out if you still get this as 50 joules, which is right over here, marking C. Done and dusted. C option also done. Yep, very good. Now what is the last part saying? Compare the answers in B and C. In B, I got 50 and in C also I got 50. What does it mean? What does it mean? How many of you can think carefully and tell me? The work done by the force is 50 joules. The kinetic energy of the wheel is 50 joules. Oh my God, what is this? What is this? They both are equal. Why is it? Work, kinetic, energy, theorem. Work, kinetic, energy, theorem. Whatever we had studied in work, power, energy. Exactly, it had to be equal. How can it not be equal? Whether you calculate like this or whether you calculate like this. Even without doing all this nonsense, still you could have told this. You didn't have to do all that. That is the reason why this question is mentioned. Compare the answers. Yes, they are equal because of work kinetic energy theorem. Exactly. Very good. Very good. Wow. Are you now ready for angular momentum and conservation? Are you now ready for angular momentum and conservation, my dear students? Yep. Are you ready? Wow, very good. Okay, before that, shall I ask you a nice riddle? Shall I ask you a nice riddle? Shall I ask you a very cool riddle? Okay. I'll ask you a very funny riddle. Very funny riddle. Okay, get ready for your minds to be blown. You're like, sir, what nonsense, sir. Okay. Cool. You know, if you have matchsticks, also you can do this. If you have matchsticks also, you can do this. In front of you. This is like your digits in your calculator or some olden computers or in your wall clocks, digital wall clocks. First of all, count the number of matchsticks or count the number of sticks that are there over here. How many number of sticks can you see on this? Come on, my dear warriors. Quickly. How many number of sticks are there? How many number of sticks are there over here? How many number of sticks are there over here? Count it. 1, 2, 3, 4, 5, 6. Oh my god. Why am I? Oops. Yeah. 12. Paka? Okay. 6 here, 6 here. Very good. 1, 2, 3, 4, 5, 6. Very good. 1, 2, 3, 4, 5, 6. 12. Very good. Now, question is only move exactly 2 sticks. 2 sticks, and somehow you try to get 25. Now I think it is looking like 99. Try to get 25 some way or the other. Some way or the other. Which sticks are you going to move? Which sticks are you going to move? Come on. I'll mark the sticks if you want. A, B, C, D, E, F, G, H, I, J, K and L. Which sticks are you going to move? Which sticks are you going to move and where, so that you get 25? Done. Jagan, just search for ray optics, Shreyas sir, you will get it. But this Friday, if I'm not wrong, or this Thursday, I'm conducting a ray optics marathon. So wait for that. I'll be just doing it. Done. Janice, which and all? Come on, come on, come on. Harsha, this is like a break only. Riddles are like a break, right? So that's why I've given you a riddle. If you want to refresh, wash your face, please do that. H. No, you have to move 2. You have to move 2, okay? You have to move 2 matchsticks. It is a waste of time, Mathan Ravi. Why will you solve J advanced question when the paper of NEET is much lower, simpler and very different than J advanced? It's of no use. It's a waste of time. You can do it for fun, for more concepts, but you see the papers, level is very different. It will be making you lose the confidence. D, E, H, D and H, is that so? I don't think you can move 3 things. I will tell you what you should do. Okay, observe. I am going to move only C and H. I am going to move only C and H. Most of your answers are wrong. See, A is here, B is here, this is here, this is here, this is here. Here also, this and this. This C and this H I will move. The C I will keep it here. This H I will keep it here. What is this? 5 into 5, how much it is? 25. Done and dusted. 5 into 5 is 25, my dear students. I didn't tell you you have to get 25 like this. When did I tell you you have to get 25 like this? For getting this, you will have to move more than 2 matchsticks. So this is not possible only. This I didn't even ask. I just asked you to get 25 somehow. So this is thinking out of the box. This is also called as lateral thinking. Thinking beyond, your standard linear way of thinking. How many of you are mind blown now? How many of you are like, oh my God, sir, what is this? I never expected. I feel like throwing the book now, throwing the mobile now, banging my head onto the computer wall or something. Ask your elder brother, sister or parents or your friends in the school tomorrow and come back and tell me and comment on the video. How was their reaction? What did your friend or your parents or anybody whom you asked, reacted? I want to listen to all sorts of funny stories. Okay. So anyways, let's start with the class. The actual thing. Yeah. Angular momentum. Let's talk about it. So a particle which is thrown has momentum. A particle which is thrown and you are measuring it about an axis, like if I slap you like this, top, nice, you will be thrown out now. But if I slap you like this, nothing will happen. If I slap you like this, gone. 2-3 teeth will also come out. But if I slap you like this, nothing will happen. You will get hurt, but not so much. So that is what angular momentum is. It depends on the momentum as well as the distance at which it acts. So if there is a particle of certain mass having certain momentum, which is m into v, that momentum can be split into two parts. One is the momentum which is perpendicular to the position, and the other which is parallel to the position vector, Then the angular momentum is a vector. Which is perpendicular to the entire plane containing r and p. It's just like torque. That angular momentum is defined as r cross p. Magnitude wise it is rp perpendicular or just rp sine theta. That is just the magnitude of it. Okay, so r cross p, vector product, that's all. Vector product of position vector with momentum gives you the angular momentum. If I ask you what is the unit, of angular momentum, quickly think and tell me. This r is meter, this momentum is kg meter per second. So it will become kg meter square per second. That is the unit of angular momentum. Very good. Now this angular momentum formula works for particles. So this angular momentum formula, whatever I have given you over here, this is for the particle. For a particle, you can easily find out the angular momentum. Like for example, imagine I tell you, listen, there is a 5 kg mass, and it is traveling with a speed of 20 meters per second and making certain angle over here, let's say 30 degrees, and you are at a distance of 4 meters over here standing, and question is find the angular momentum about point O. This is the question. Now look at this. I am standing here. With respect to me, angular momentum has to be calculated. Mass is moving at 20 meters per second at an angle of 30. So where will the momentum be? Always in the direction of velocity. So momentum will be here only. Now split the momentum into two parts. One momentum is here, one momentum is here. Which momentum will you consider? Like in torque and like shown here, always consider the momentum which is perpendicular. Never worry about the momentum which is parallel. So, will you worry about this component? No. Will you worry about this component? Yes. How much will it be? Mass into velocity. It will be basically cos 30. It will be basically cos 30 component. So what is the mass? 5. What is the velocity? 20. What is cos 30? Root 3 by 2. 2 and 20 cancels. 10 5s are 50. So 50 root 3 is the momentum which is in the perpendicular direction. So in order to find that angular momentum, it is r into p perpendicular. R is 4. It is r into p perpendicular. So how much is r? 4. And what is p perpendicular? It is 50 root 3. So it will be 200 root 3. What were the units? Kg meter square per second. So just put it over here, kg meter square per second. So that's how you find the angular momentum. If the direction of the angular momentum is asked, if you notice, this velocity is trying to rotate it like that. It's trying to rotate it clockwise. So the angular momentum is clockwise. But if you use your right hand, rule, clockwise, curl the fingers clockwise, the thumb goes inside. So the angular momentum will be inside the board. If it was outside, it will be a dot. It is going inside or it is going away from you. It is going away from you. If it is coming towards you, I'll show it as a dot. Right? Everybody understood how to find the angular momentum of a singular particle? Angular momentum of a singular particle, everybody clear till this point? Very good, very good. Let's move. Just one second. Great. Now, what if I don't want to find the angular momentum of a particle, but it's a big body. I don't want to find the angular momentum of a particle, but it is a big body. Like this one. Rigid body. And let's say it is rotating about certain axis over here with some angular speed omega. So the moment you have a rotating rigid body with some angular speed, then how do you find the angular momentum? Just first of all, I talk about the direction. If it is rotating like this, curl your fingers in the direction of rotation. See where your thumb goes. So if the thumb is going like this, so angular momentum vector will also be like that. Whatever direction your thumb points, when you curl your fingers in the direction of the rotation, that is the direction of angular momentum. But the value of the angular momentum is simply I omega. That's it. It's just I into omega, just like mass into velocity. Try to remember how linear momentum was. Mass into velocity. Just like mass, moment of inertia. Just like velocity, angular velocity. Just like momentum, angular momentum. Very easy to remember. Very, very easy trick to remember this. Is that very, very clear? How to remember angular momentum of any rigid body? So say for example, I tell you, a disk of mass 2 kg rotates and 2 kg and 0.5 meter rotates at 20 radian per second. Find the angular momentum. Okay, let's try to do this question. So in order to find the angular momentum of a rigid body, we use this formula. When it's a particle, we use MRV or R cross P formula. R cross P is for a particle, and I omega is for a rigid body. So this is a rigid body, it's a disk. So L will be I into omega. For a disk, I is mr square by 2. What is the mass? 2 kg. What is the radius? 0.5. So square it by 2. What is omega? 20. 2 cancels. 0.5 square is 1 by 4. And this is 20. So how much will it be? 5 kg meter square per second. So that's the answer. How many of you wrote 5? Very good, Siva Prasad. You are really quick about it. Very good. Proud of you. 5 is the answer. Awesome. Now, I'll tell you one interesting thing. Torque and angular momentum are actually related. And the hint comes from Newton's law. In Newton's law of motion, specifically the second law, what did it say? The total force acting on the body is the rate of change of momentum. Do you remember this? Newton's law. Total force acting on the body is the rate at which the momentum changes, or proportional to it. In SI unit it becomes equal to. So you know what happens in rotation? In rotation, instead of force, what will you get? 100% you will get torque. And instead of momentum, what will you get? Angular momentum. That's it. So this is net torque on a body. Net torque on a body is the rate of change of angular momentum. The rate of change of angular momentum is a very, very important formula which directly comes if you compare Newton's second law in translation. Now we come to the special case. If torque acting on a body causes the angular momentum to change, and if angular momentum changes rapidly, torque is also more. If angular momentum changes slowly, torque is also less. So my dear students, tell me in a scenario, if it so happens that the net torque only is 0, that is, there is no torque. If no net torque acts on a body, that means there could be torques, but they cancel out. One torque here, one torque there, one torque like this, one torque like this, but they all cancel out each other. In that case, Ria Medical, it is same, Captain Shreyas. You can see that right over here, right? Captain Shreyas, I don't know, you see this. Yes, Captain Shreyas, everywhere. Telegram, Instagram, everywhere. Okay, Twitter, whatever you want to see. In that case, what do you suggest will happen to the angular momentum if LHS is 0? dl by dt will be 0. dl by dt will be 0. Think about it. Yes or no? dl by dt will be 0. Come on, think derivative. When is a derivative of a function 0? When is the derivative of a function 0? Only when it is constant, 100%. So therefore, I can say angular momentum is constant. That means I can say then the angular momentum is conserved. Then the angular momentum of that body is basically conserved. A very important law of conservation of angular momentum says that if the total torque on a body is 0, then the angular momentum is conserved. Now let's see a very funny example of this. Let's see also a realistic example it is. It happens in many places. Okay, let's have a look at that example. Shall we get Champa? Yes or no? Shall we get Champa? Okay, let's get Champa. And what is Champa going to do? Dance. Look at this beautiful Champa. Oops. Wow, little difficult. Let me draw lipstick also. Beautiful. Yeah. Oh my god. This Champa is not looking that beautiful or graceful. This is some Champa. And what is this Champa doing? She is dancing. And when she is dancing, she is rotating like this. She is rotating like this. Everyone? Yeah, she is rotating like this. She is spinning. Cool. So that's her spin. That's her initial angular velocity omega naught. Then you know what she does? She brings her hands very close. Even the legs also, she brings it very close. So something like this. Very, very close. And even the hands. So graceful. This is her beautiful lipstick. Now think and tell me what will happen to her angular velocity. She was rotating like this, then she brought her hands close. She was rotating like this with hands open, then she brought her hands close. What do you think will happen? What do you think will happen? Yeah, tell me. Think, go back. If the net torque acting on a body is 0, if there is no net torque acting on a body, then the angular momentum is conserved. And for a body, what is the value of angular momentum? We just saw it is I omega. For angular momentum of a body, we just saw it is I times omega. Champa is also a body, so she has I, she has omega. And is there any torque acting on Champa? Is somebody pulling or pushing her? No. Is some Pandu there? No. Is somebody else there? Some ghost, some dragon, somebody else is there? No, right? Nobody is there. So can I say in this scenario that the net torque acting on Champa is big fat 0? So that means angular momentum of Champa is a big fat, is a constant. That means moment of inertia of Champa here into omega naught will be equal to moment of inertia of Champa here into the final omega. Let's say I call it omega 2. Oh, now where is moment of inertia more or where is it less? 100% it is more here. 100% it is more here because our arms are spread wide away. R is more, radius is more, so mass distribution is more, so moment of inertia is more, but here I is less. That means to keep the product same, what will happen? What will happen? Omega will increase. So this will be omega 2, which will be more than omega naught. She will spin faster. Zook. First she'll be spinning slow. As soon as she gets it close, she'll spin faster. When it is far, it will be slow. But the moment she gets it close, she will spin fast. That's what is going to happen. And you can see this practically also. Yes, the angular velocity increases. Siva Prasad, Jania, Sanvi. Yes, it does. That's a beautiful, beautiful example. Okay. So let's solve some questions on angular momentum coming up on your screen. This is the last part. Last set of problems. Get ready. Particle moves on a straight line with uniform velocity. Angular momentum is always 0. 0 about a point on a straight line, not 0 about a point away from the straight line. About any given point remains the same. Particle is moving on a straight line with, yeah. Oh, by the way, this is MCQ. More than one is correct. Multiple choice, multiple options are correct. Try to think. Is always 0. Particle moves on a straight line with uniform velocity. Particle is moving on a straight line with some uniform velocity. If I am standing over here, definitely there is some r. Definitely there is some r. Angular momentum is not 0. So is always 0 is definitely wrong. Is 0 about a point on the straight line? Yep. If I take a point over here, then this will be r, this will be r, this will be v. R cross v will be 0 because theta is 0. R and v are parallel. If you are standing along the same line, then you will see r cross v will be 0 because theta is 0. So this is correct. Is not 0 about a point away from the straight line? Yes. Is not 0 about a point away from the straight line? Yes. We saw that right over here. If you are standing away, it is there. About any given point remains constant. About any given point, it remains constant. So if you take this point, what do you think? Angular momentum will remain constant or not? When it is here, after some time it is here, after some time it is here. If you notice, if this was my point, although my r might change, what remains same is the r perpendicular. This is my r perpendicular. Just like torque was r f perpendicular, r perpendicular f, here also angular momentum is r into p into sine theta. or it is r into p perpendicular, or it is r perpendicular into p. Neither r perpendicular changed, nor did the momentum change. The momentum just went on. Here, here, here. Same momentum, same r perpendicular. On the line of momentum, you draw perpendicular, it's the same. So it didn't change. So hence this is also correct. So B, C, D, yes, B, C, D, all the three options are correct. Yep, perfecto. Let's go to the next one. Two particles, this is NCERT question, they cross in opposite directions, parallel line separated by distance d, opposite directions, show that the angular momentum will be, two particle system is the same, whatever be the point about which the angular momentum is taken. You can just take two random points actually, or take it. This is a mass m, this is velocity v, this is another mass m, this is another velocity v. You choose some random point, let's say over here, about which you want to measure the angular momentum. This is one r, this is another r. Notice what happens. This velocity I can extend it, even this velocity I can extend it, and I can draw r perpendicular. This is, let's say, r1 perpendicular, and on this particle this much is r2 perpendicular. For the particle 1, the angular momentum will be r perpendicular, which is r1 perpendicular, into the momentum, which is mv. And because it is going this way, it is clockwise. I will take it as positive. For this mass, which is going like this, r perpendicular is r2 perpendicular into momentum, which is simply put mv, and that is going anti-clockwise, so I'll have to put a minus sign. Now if you notice over here, nothing is changing. This is constant, this is constant, this is constant, this is constant, this is constant. Everything is a constant, so even angular momentum is a constant. Nothing will change. So that's why the angular momentum remains the same no matter which point you choose. I had chosen some random point. This was some random point which I took, and r perpendicular remains the same. You can see that. So nothing will happen. Cool. Let's go to the next question. Solid cylinder. Yeah. I think this first part we had done. Kinetic energy we had done in the previous part. Remember? The kinetic energy we had done this. Now we have to do the next part. What is the magnitude of the angular momentum of the cylinder? What is the angular momentum of the cylinder? Angular momentum is I omega. Solid cylinder means mr square by 2. So what is m? 20. What is r? 0.25. That means 1 by 4 whole square. This whole thing divided by 2. What is omega? That is 100. Come on, do the math. 20 by 2, 10. 1 by 4 square is 16. And this is basically your 100. 16 goes with 10, 5. This will become 8. This divided by 4 becomes 2. Divided by 4 becomes 25. 125 by 2, which will become 62.5 kg meter square per second. That should be the answer. Check this out. Everyone? 6250? No. 62.5. It is 0.25 meter. I think you missed that decimal. If you miss the decimal, you will get it in a slightly different answer. Yeah. Okay. Be careful. Next, there is a rod which is rotating like this. This much is L, this much is 2L, pivot point is over here. Question is, find the angular momentum of the rod. Now many people try to do it in a different way, but I will tell you easiest way to do the problem. Treat this not as a single rod, but as two separate rods. Find their angular momentum individually and add them. That's all. If you notice, this is one rod and you are connecting it at the end, and this is another rod and you are connecting at the end. And remember, the moment of inertia of the rod at the center is ml square by 12. But at the end, remember we had done this, it was ml square by 3. We did this using parallel access theorem. It was one of the problem only. It was one of the problem which we just did at the start, very beginning. So what will happen if you use that? Let's see what do we get. The total angular momentum of this part, ml square by 3. The angular momentum of this part is, how much is the mass? Uniform rod of mass m is rotated. Okay, now you need to be careful. Say if before writing this, the total rod, if the total rod had a mass of m, this is L, this is 2L. Think about it. The total rod had a mass of m, this is L, this is 2L, divided in the ratio of 1:2. How will you divide it in the ratio of 1:2? One mass will be m by 3, other mass will be 2m by 3. So who is m by 3 mass? This one. This is m by 3 mass. So when you write the angular momentum of this guy, put m by 3 into L square divided by 3. Did you understand? M is the total mass. This will not have m mass, it will be 1/3. Because if you divide it into 3 parts, L, 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 each part will be m by 3 mass. Next, this 2m by 3, this will be here. So how much will be the moment of inertia? I omega. Moment of inertia will be, my bad, not I omega. It is just ml square by 3. M is 2m by 3 into L. L is 2L whole square divided by 3. Now comes the final thing, which is the total angular momentum is I into omega plus I into omega. So now you can solve this and get the answer. So you can see many terms like m, L square, omega by 3 is common. Few things will remain inside which you can solve very easily, like 1 by 3 is over here, plus here you have 2 by 3 into 4 right over here. Again 3 can be taken outside, so ml square by 9, 1 plus 8 which is 9 again. Okay, just check it out if it is ml square. Just check it out if it is ml square. 9 gets cancelled. 2 4s are 8, or 8 plus 1 9. Yes, ml square. Oh, I forgot that omega right over here. Yeah, omega is there. Yeah. So ml square into omega. That's the answer. Is that okay? So beautiful question because the masses were different. Otherwise there was nothing in it. Let's say meanwhile you can solve this question. Let me drink some water. A person is sitting firmly on a rotating stool, arms stretched. If he folds his hands, we just did this Champa question, dancing question. If she folds her hands, what will happen? Moment of inertia will go down, but angular momentum should remain constant. So omega will go up because angular momentum is a constant. It should be conserved. So omega will increase. So answer should be A. I think there is a printing mistake. Ignore this slide. It should be increase. Yes. Correct. How many of you wrote this? Oh, angular momentum will, oh, my bad. Question is not angular speed. Question is angular momentum. So sorry. Angular momentum will remain unchanged. Yes, angular momentum. Angular speed will increase. So even then this is wrong. Don't worry about it. Okay. So even then that option B was wrong. Option C is correct. It was not angular speed. It is angular momentum. And in the exam, if you read it as angular speed, dush, dumon, gone. Full on. Bombs only. Completely. Okay. A thin horizontal disc is rotating about a vertical axis. There is a vertical axis. Insect is at rest at a point at the rim of the disc. It moves along the diameter. Find how will the angular speed change. Simple. There is a disc. There is an insect. What does it do? It starts moving like this and reaches here. crosses the center also. Now, what will happen is, in this part of the journey, insect also has a mass. That mass is coming close. Because of that, what will happen? If the mass is coming closer, the moment of inertia will become less. Keep that in mind. Next, when it again starts continuing its journey from here to here, it's going away from the center or the axis. Remember, this was the axis, vertical axis. I'm looking at it from the top. So what will happen? Moment of inertia will increase. Moment of inertia will increase, yes or no? So, my dear warriors, what do you think? Omega should here decrease, here omega should increase. So first omega increases, then decreases. Question is on angular speed. It increases, then decreases. C for Captain Shreyas. C for chemistry. Very good. Janice loves chemistry. Very good, very good. C for chemistry, C for Capto, C for Champa. Very nice. Next, a child is standing at the center of a turntable. Turntable is set into rotation. How much is the new angular speed? All these questions. Now I'll tell you what, I feel you can do this question very easily. I will show you a beautiful, simple question right over here. With this, you can easily solve this question. It's exactly the same thing. Child is standing in a turntable, hands is stretched, angular speed is omega something. How much will be the new speed? If the new moment of inertia is 2 by 5 times of the original value, all you have to do is I1 omega 1 is I2 omega 2. Just use that, you will be able to solve this. But find the new kinetic energy in terms of the old kinetic energy. So for that, K1 will be half I1 omega 1 square. K2 will be half I2 omega 2 square. You will see both of them will not be equal. In fact, you will be able to show that the new energy is actually more than the original kinetic energy after solving the problem. So that's all. You have to find K1, you have to find K2, and you will see that this value happens to be more than this. So please try this out as homework. I have given you the hint. It is there as NCERT back exercise. Will you be able to do it? Yes or no? Let me know by lighting up the chat box. Let's light up the chat box. Put some fire in the chat box so that I know, yes sir, I will be able to do it. Tell me if you are warmed up for that. Yeah? Very good. Very good. Very good. Awesomeness. You can see a lot of fire in the chat box now. Cool. Let's do this question then. A circular ring is rotating. Two particles are attached. Find the new speed. Very similar to previous one, but I feel that we can do this because this had come in JEE Mains and this can also come in NEET because it's not very difficult at all. So there is a ring of certain mass m, radius is r, and it is rotating with angular speed omega naught. Then what happens on the ring, you put two new masses over here, m and m, at r distance and at r distance. Obviously the ring still has that mass. There will be a new velocity. In this process, no torque is there. In this particular process, torque is not there. So angular momentum is conserved. So therefore, I omega or I1 omega 1 will be the new moment of inertia into the new omega. So that's all you need to do. Initially it's just a ring. So it will be mr square into original omega is omega naught. Here, be careful, there are three masses. One is the ring which is having mr square. The other one is this mass at a distance of r again. So again plus mr square. Again this mass at a distance of r again. So again plus mr square. These are point masses. The new omega I don't know. Notice how r square will get cancelled. Here, here, here and here. So what am I left with? Omega 2 will be, m omega naught will be on the top, whole thing divided by this capital M, m plus m is just 2m. That's the final angular velocity. It is quite different from the initial velocity because you attach two masses. So you will see, to conserve the momentum, you will change the angular speed. Cool? Very nice. So we have come till the end of the session. And if you have watched this class till the end, I'm really super duper proud of you. There is an assignment daily practice quiz also in the description box below. Please make sure you open it up and solve it. If you're feeling sleepy now, it's okay, you can solve it tomorrow too, but solve it. If you're watching it recorded, good. And hopefully there is time left in your day. Finish it and I will be very happy because it's 5-10 questions, nothing more. Okay? And how many of you are going to put this comment up? Rotation monster defeated. How many of you feel that today? Please put it up, not in the live chat alone, but also in the comment section below after the video ends. And please like, show that love and support, because we had a very big class, more than 5.5 hours almost. And please subscribe to the channel and join the Telegram group so that you get today's big PDF. So yes, rotation monster has been defeated by the NEET warriors. Kudos to all of you. Proud of all of you, my dear students. I will see you again very soon. Meanwhile, please sleep well, solve the DPP, keep liking the videos even before the session begins. Shows your love towards the channel and the teachers. Thank you so much. Have a lovely day ahead. Hasta la vista, Captain Shreyas signing off.